Hello and welcome to Sunday, another fine evening for some Rustbot programming. We're going to be going back to Hypersonic today. We're going to get into it with a little competition as we usually do. And we didn't make it out of the Wood Leagues last time, but today we'll most certainly make it out of the Wood Leagues. I pretty hope that. And we'll see how far we go. We're going to start with Cheap Strategy. Hey Kreis, how's your bot going? Are you making it quite far in the contest? Do we have to catch up here, or did you save the excitement for us as well? Kreis was with us. He started coding on the exact same thing we did last week. He found us interesting. He's doing really well. That's good to hear. And we'll get there right away. I'm gonna do the quick Clash of Code, and then we'll get back to the game. And we love to start with Clash of Code because my mind's not into it yet. It's really weird. I have to. As much as I don't necessarily like doing this too much, the Clash of Code is a good transition for me. It's been a nice sunny day here in Munich today, so I've been outside in a beer garden walking around and programming. I haven't done this since this morning, if you can imagine that. And this morning I was doing compiler stuff. I need to implement a size-of operator for Leaf. Yeah, and lose my train of thought. I have to really stop. So this is a Clash of Code, and I'm just going to go over to the Evening Rust one here, and this is the site we use to keep the tools and stuff updated. Haven't changed it much lately, and I'm just going to get the link for copy link location. Here we go. If this is a fast one, hearing us stream won't help AirTBX help at all, because I mean these usually don't make a big difference. And if it's a coding golf, as much as I don't like coding golf, it's actually very relaxing compared to the fast ones. The fast ones, I mean, like last time we lost by like 8 seconds. You're having to code stuff within like a minute, and it's just like any blip of thought failure, and it's like, oh no, you're third or fourth. But I mean, this is it's not so bad. The reverse engineering, we get a little bit more time, but I've actually screwed up. I never liked the reverse engineering at all before, because the first one I got was ridiculous. Hey Marconi, you're on TV. Hi Marconi's mom. He wishes to say hi if you're watching. So yeah, the first reverse engineering one I got was so difficult that I hated them. But every one since I got since then has been actually reasonable and actually morally a speed thing. So we're going to find out what's going on there. We're just waiting for one more player to join. And I say, once we're done with this, we got the joiner. Once we're done with this, we'll go on and do the hypervisor or hypersonic. Oh, it's golf, so we can relax. Where's our little size indicator? It's right over there, 776. We're going to do this in the editor here to save us some times. You must help Gary move X boxes. He can carry 1 box per n minutes, but he only has T hours to do so. You promised to help, but since you're very lazy, you will only carry the minimum number of boxes that are required for Gary to finish. This looks like a simple mod, doesn't it? So Gary can carry 1 box per n minutes, but has only T hours to do so. So I guess Gary, we'll just do it quickly. Gary is going to carry T times 60 divided by n, right? This is how many boxes Gary can carry. What do I have to write out? The number of boxes I have to carry is that simply n minus g? Let's find out. Cries. No, Cries. We have to do the manual collapsing. It's really annoying. I really wish we'd remove code size, but the last step I do is to collapse all the tabs and line feeds and all of that stuff. Found. Okay, so we got something wrong here. Yeah, we never won with this, but it's just fun to do them anyways. Carry 1 box per n minutes, but he only has T hours to do so. T times 60, this is the number of hours. And divided by n. This should be rounded down to 0. And... oh wait, that's just stupid. Times n. What am I doing wrong? Oh wait, no, sorry, I just got this totally wrong. C minus 60 divided by n. That's another box that says x minus g. What am I thinking here? So this is what I had to do, is get into the case. So this probably works here. Yeah, Christ, now it's just a matter of minus 4. What the hell? Oh, there could be a maximum. Max 0, is that what the code is? There we go. Alright, so we have the basic code. Now we just have to shrink it down a bit. The parse input we're going to keep. There's a way to do this all in one line, and I've forgotten how to do it. First off, we get the line to dot into, and then we do all the structural stuff first before we do renaming things. Having to read 3 lines is a bit of an issue. There is a way to read multiple lines in. How do you read all... If we read all the lines at once and just parse along the white space, we've done that once before. That might help. Then we have 3 variables. How do I read the entire file? And I keep... How do I do that? Rust, read entire file. I don't know if that's exactly what I want. Read. Is there a way to read? See, this is where it slows me down. Read to end? Would that work? Read to string? Standard init lines, thank you. Okay, but how do we do this? We have to do this in... Alright, how do I want to do this? Let q equal IO standard in dot lines. I hope this is an iterator. This is already an iterator. Dot map line. Parse input L, comma I32. We'll see if this works. If not, dot collect vec I32. See if this compiles first of all. No method named lines. We had this problem before. I don't know if we ever figured out how to read this quickly. We want to read every line in the same way. Well, let's try it out. We're a reader. Probably gonna need to import something. This is when we do too much stuff to do the correct way. You end up having more code. Do we have to use a buff reader somewhere? Is this just part of buff reader, or I'm gonna guess here? No buff reader, you rust. Buff reader, come on. Buff reader. Standard IO buff reader. So you can see where this starts getting longer. This is the problem with golf, is because you have this overhead, is that any attempt to minimize it gets it slower. Lines. Now, it seems ridiculous that we have a result type here. Why would this be on a result type? That doesn't make any sense. Alright, so this is not working. I'm just going to do it the other way. I don't know how to get this working. It doesn't make sense to parse input. Why on earth would map ever give a empty option? This doesn't make any sense. If I have lines, iterator, and map, I should never get an empty result. There's something I'm missing. It just doesn't make any sense. So let's try to reduce this first. Yeah, Cries, I know it's the line, but I'm calling map on lines. Why on earth would I ever get a line that's not there? That doesn't make any sense. Yeah, no, but if there's nothing here, the map shouldn't be called. Right? I mean, why is map being called on an empty line? It should only be iterated on the lines that are actually there. Yeah, well, okay. I find that I can't understand the explanation right now. And there is an airline. It actually reads incorrectly, so this is kind of silly. What we can do, though, is just put this up here. We could put the line up here, I think. And I don't know if this will help any. Let's just do it the other way. See how much we can get it down to here. Don't have to care about that. And this can actually do... Yeah, we need to do an il.clear. This is a slow way, so this is one of the ones when you have to read a lot. There's not much we can do about it in Rust. There's really no simple way to read the input other than reduce the name sizes here a lot. I really wish the map would work, but I don't have time to look and figure out why it's not working. Let's make sure this is still working. I think I just get rid of that. Get rid of that. We don't need that. Okay, see, we can remove the parse input just down to P, of course. I don't know if read to string works. We could try it, though. Let's try that again, then. Well, we don't need to do the lines then, because we can do a split on it. Split white space. Dot map. L. We'll just do this P. L I32. Just want to see if this works. Dot collect. Beck I32. Oh, read to string, okay. Well, that's not likely to help us then. Because watch what happens. Like, this is super hard to get small, and we know that before. And there's no method named a string for standard in. So this is the same thing with buff reader. You know, I'm just going to shrink the code I have. I'm not going to keep looking at it. We know we don't win these things anyways. So let's just reduce it. Because every time we've done this trying to get this mapping, we've never got it reduced. We've always had the same failure. And well, I could try it again, just to make sure I use standard IO, just in case there is a simple one. But then we'll give up on it because we are running out of time. No, let's just do it. We're running out of time. Let's just see how small we can get it. It's the other way. And I could probably put this stuff in here. IL, we could probably put it in here somewhere. IO standard in. Why is it continuing on me? And mut. And mut$x. Does that actually work? Why can't I put multiple lines in here? Come on. Come on, come on, come on, come on. Like this. I can't do that. I need to do... Oh, come on. I don't know how to do these macros. I've never liked the macro system, because I don't know how to do it. There's got to be a way to do it. Ah, fuck it. I mean... I always have this trouble with the macro system in Rust, to be honest. There's something wrong with it. Yeah, I can do at least that. But I should be able to do the whole thing in the macro, but it's always been a tricky thing for me to get the macros right. Because I'd like to get rid of the read line, but I'm running out of time here. We gotta see if this shit works. There's really not much left for us to collapse here, so... Oops. So we're still okay? Hope I didn't screw up the last bit. There, I still got it. So, I don't know why the map didn't work. I don't know why the macro didn't work. I've had trouble using macros, and we know we can't win anyway. With Rust, we just can't compete with this 39, and we just got into it, though. At least we got it working, and we know it. We theoretically what we want to do, and I'm willing to bet some of these guys are using some sort of mapping on those lines. Very simple. They just read it directly, and yeah, right. This is what I wanted to do in Rust. Just this map, and this is ultra compact in Ruby, so this would actually work. But this is exactly what you want to do, this map. But this map is turning out to be ridiculously complex in Rust, and, well, not working for the macro. And what else did the Python guy do? Python also did a map on the input. And there is no shortcut for the input in Rust. And it is one of those trouble points I have, actually, with Rust, is reading from files. They have all these things like read to string, iter, lines and stuff, but it all seems to be a big mess because every single one's a different package, doesn't work the same, doesn't have the same types, and it is really hard to just read stuff from a file. And because not all the types are the same way, but even if they, I mean, that's not the biggest problem we have, it's just it's overall too big, but it is one of kind of complaints about it. Now let's go back to Hypersonic and join this and see where we are. Cries. Yeah, okay, we have an older compiler here too that makes a big difference. And okay, now let's open this up. We wanted to have all this stuff. External code editor. Oh, why is it? I have to select a file. That's weird. Source/evening rust-private Hypersonic single file. Let's upload this guy. Now, where we were is we had this file. We didn't even write this new thing. What I wanted to do first is the first cheat. Let me close this first of all. And we know that we might be able to get away with in this code. So Hypersonic, for those joining us, and let's put a promotion on here. Why not? And copy link location, let everybody know that we're here. And let's do that. Let's do the gen E1 too. We don't spam them very often. Just sometimes. So the first goal, as we knew from last time, is that when we do the entry point here, and we read all these moves, somebody actually indicated that, and we figured out if you just ignore all this, ignore the whole strategy thing, because most people die. This was exactly what I was going to say, Rekna, because I think this might work now. We're going to try it again. I don't know how I was going to do it, but let's see how far that gets us right now. And we're going to find out, because if enough people did it, you might be able to move far enough in the league, or we'll have to go down and kill one box or something, and this becomes player.position. I'm going to have to get y-x, player.position.y. We'll see if this actually lets us get anywhere. I better save that. Clear and cargo build. Player, oh yeah, I gotta put those in the right order. So the strategy attempt here is basically, can we do a cheat? Can we just, sit in the corner and not die? They might have fixed it a long time ago. Who knows what it is? It's trying to tweak. Why is the computer player not dying? He's supposed to be dying from his explosions. I thought it said it changed. Oh, only enemy bombs. Uh-huh. Yeah, well then we're gonna lose. We have to actually go kill some bombs then. Okay, so let's do... Do we actually have to do the walking to figure it out? We won't get very far, so we're going to actually have to do something. Now, I was wondering, should we actually start walking? Should we actually start the A-star scanning now, or is there a cheaper one to get to the next league first of all? And let's find out what we have to do. Yeah, that's basically, when he says flood fill, I mean that's what the A-star would do, but I guess this would work better. Well, I already have the nearest box, and I just want to get to there. Alright, we're going to have to change this. Oh, we're going to have to do some actual work here. Good place to bump. Actually, we have to read the change the reading of the board, because we don't read in the state first. We don't have the boxes. We just quickly push those in. There's walls we have to read into. Walls, 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 walls. And what do we have? Come on, come on. What do I have to read in for the wall? An empty box. X a wall. Where am I reading the wall? 0, 1, 2. We only have that. X a wall. Yes, Christ, we will definitely try to fight against yours. Not yet. I want to actually do something first. Alright, so we need to actually have... A wall. We don't even represent the board yet. Oh. Oh, man. That's bad. We don't even have a board yet. We managed to get this far without a board. And I think it was Tron was the last place we had a board. Tron. What do they call Tron? Is it Labyrinth? Thor? Panic? Skeleton? To a code for life? Bodies? Temperature? Golf? Shit, when was the last time we did the... something with a grid on it? Great, not that. Not Thor. Don't Panic, no. Temperatures, no. Labyrinth, no. Code for life, no. Did we not even have anything for that yet? Wow, that was using the old setup still. Tron, there it is. Let's just grab the old matrix. Wow, Kry's already in gold. Wow. Very good job. We're putzing about here doing nothing. I'm looking for a matrix class and you made it to gold, so that's wonderful. And 26 or so in gold. Wonderful. You're going to catch Euler there soon. So, okay, we're not going to play your bot just quite yet. We're going to have a bit of an issue playing him now. Alright, so we have this matrix type. It has a size, a width, and a height. And again, we're using an integer here because it's more natural. And this push is a bit weird. And we have this linear stuff. This is all from there. And we have a point. We have an I point to is what we need to do in this matrix using use I point to star I point to. And these I points actually have an X and a Y in them, I think. Yep. Dot X, lock dot X, lock dot Y, lock dot Y. There was something different before. Self get dot lock, get dot lock. This is an I point to. Lock dot Y, lock dot X. I don't know if this is the best name or not, but it'll work for now. And our state then, our state has to have more in it. A state has to have a board, and we have to have a enum cell type. It's going to be empty. Be a wall. Recognize I changed it just because in this code we already have a class called iPoint, which is an integer point. And because in our other code we're using floating points as well, and there's a possibility we wouldn't have to use two, so I'm going to start distinguishing I point and F point probably. And because Rust seems to love compact names like F and I, I'm just going to stick with that. This should actually be an I32 point or something like that then. Wall, and we'll say box. I don't care what's in the box right now in the cell type, I'm just going to say box. And then we have a pub. Grid is a matrix of cell type. And this has to derive from stuff as well. Derive, default, clone, debug. Implement default for cell type. Pub function default. Cell type empty. This seems like a reasonable default. You have an empty cell type. Now we have this grid, and we order to create the entry. We create the state here somewhere. going to do the state a new way. We're going to actually make a constructor for the state, so it no longer has a default. Public function new. What is this? Initialize a new matrix T. That's fine. And this becomes a state. Should probably be a size, just to be consistent here. Size? I don't have the ID yet, that's fine. And a grid is going to be matrix cell type new. Hey, look, RLS is working for a second. It'll probably go away. New size. And over here, we're going to move the state down. Put this down here. Scatter this a bit. State new board size. Let board size equal, and that should read that in. And my ID that. So we read the state in now, and that gives us a state. That gives us a board. And the state should probably fill the board. Christ, because I want to put stuff in the board. I want to put the boxes and bombs on my matrix board. How else do I know the side if you need to read it in? Have you just been using a fixed size? Did you mean like the game is actually on a fixed size grid and it never changes? I didn't realize it was constant. Well, that's silly. Why the hell do they have it in the input then? I was actually working from the original code, and the original code read it in, so I just assumed you'd read it in. Yeah, well, I'll just leave it that way now. Because whereas it's on the input. Right, width and height. Given purely for convenience. Okay, well, whatever. Well, we have it. We read it in. I don't know why we have it. We're going to do it that way. We don't have to guess too much about that. Board's much smaller than the other ones. We state new board size. And I actually want to fill this grid with... Yeah, well, we'll just do it here. Each time we read the state in, we're going to do a state.board. It's already got it wrong. State.grid. And what do they call it? Fill. Just going to fill it with cell type empty. Let's fill it up. State nothing. So we fill it up with state empty. We're going to put the entities in the box there as well, and we're also going to put boxes on the grid. So we can do state.grid.set. And what do they call that interface? Set location value. So let point equal. Actually, let's put this outside here. Oh, was this thing stupid tabs again? Damn it. That point comma cell type box. We're going to put a box there now. State.grid.setPoint cell type wall. So now we have a wall there. And now we're going to really just have to basically change. We're reading this in. We have to find this good place to bomb now. Okay, we can do this one way. We can take a... I'm thinking too far ahead because I don't want to have to keep changing the strategy back and forth the moment we get to Bronze League. Is that in this league, basically, what we could do is we could do a reverse flood fill. We could key the flood fill based on all the positions on the board. How many boxes would they destroy, and then flood fill back to find the position for us. And that would tell us which direction we should go to get the places with the most boxes. But I don't know how well that's going to expand to the next one. But let's just do it that way first of all. Set up the... Okay, Cry says exactly what it is. So we're going to do it that way as well. That'll at least get us there that far. And I just have to set that code up. I haven't. And we'll put that over in the strategy code. Just make sure this cargo check first. Unexpected token. Um, 28. Yeah. Hey, Moderated Seal, how's it going? This stuff's weird here. Let's just do Matrix New. We don't even need that. What do you mean you can't have a... Oh, yeah, that's right. It's not a derive, it's a default. We're also going to need a partial equality on here. I remember that. Yeah, I think putting the matrix here cell type should be fine, though. Because it'll deduce the correct type. Matrix. State. I hate this stuff. I hate when you can't partially initialize. I want to do just my ID 0 for now. Entities is vec new. Pub not needed here. Yeah, okay, fine. I never understand this, but okay. Random places for pub, random places for not. Yeah, gotta put it in the lib. Pub mod matrix. Let's put these in the correct order now. Matrix is probably not public. Pub? No, not pub there. We need pub here. Pub? Pub. 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 Which is a bit weird. No method name fill in the current scope. Okay, what's that for? Copy? Do I really need to have it declared copy as well? Oh, I probably meant to have it copy. I didn't mean to have clone. I meant to have copy there. Yeah. Matrix 29 y x. Expected 2 parameters. Oh, Tron, that's from the old Tron game. That's where we got the matrix. That's our basic code. I'll close it now, so it's not in your way. And x size y. I don't know which way is the correct way to do it, but okay, let's do it that way. Keep it same. Right, so that checks that out so far. Close that off. Now we actually have to flood fill this thing, and the flood fill is going to be. Now we have to change that near box. This is actually going to become near move. Good place to bomb. We're going to make a second function. Good place to bomb is probably likely just going to go away. And what we're going to find, move to good bomb, state and state. Let me see, where are we? We'll say position. The current position is I.2. And this is going to return a... No, it's not return something else. It's going to return an actual I.2. It has to return something. So say where we have to go to from where we are now. And this is where we're going to clone the state of the matrix. We're going to do a... Too good... Yeah, okay, that makes sense. Yes, Cries, I know we're going to have to factor in eventually, but you're correct. What we're doing now is we're trying to find the position we want to do. And likely, once we have this position, this will be our heuristic one to say we want to go. And then we're actually going to have to simulate the game so that as we step through it, we don't walk into enemy bombs. But if this is going to be the position we want to go to. Regardless of what happens, we're going to say, let's go to this position. And then opportunistically, along the way, we may drop bombs or do other things. But we need to find out where we want to go first. And this is where we're going to do the flood fill. And this should have a clone operation. We can clone the matrix, wherever that was. Let's FB, just Filbert. Let's just say Filbert. I'll give longer names just so we have some ideas. State.grid.clone. And now we have to implement a flood fill. Well, first off, we have to mark all the boxes that are at good positions. So we're going to need points for all of these. We're going to do the same thing with this one. We're going to take the same basic loop. And we don't need a clone here. We need a different board. Sorry, we need a different board. We're going to have a distance board. Distance board will be... Or do we even need that? Yeah, we need that. We're going to have a distance board. And this is going to be a matrix. I'm just going to stick it here. Okay, I'm going to learn this stupid syntax. Matrix. It's going to be an I32 new state.size.x, state.size.y. Disboard.fill. Now, I always forget, what do I fill this with? I want to fill this with... Since we want the lowest value, we want to find the place that has the... We want to find the place that has a high score, so we're going to fill it with minus infinity. How do we do that again? Minus infinity, I32, minus infinity, Rust, come on, Rust, minus infinity. I remember doing this with minus infinity, I32. I forget the thing, what value it is. It's something on the I32. Something with the I32 type. Min. Thanks. I32 min. because everything's going to be better than not filled in. This is basically the value would go. This also will make boxes out of the limit. And at the end, we just have to check the 4 spots around and see what's the best spot to go to, or the spot we're currently in. So boxes within range. This returns -1 if there are no boxes within range, or there's a... Now I'm undecided whether I actually mark them on the map here, or I make these the actual seed locations to investigate in the flood fill. This is hard to say. Where do I want to do this? I want to put this... Well, let's just not mark the boxes that are 0. We want to see, so when you do a flood fill, you have a list of open points. And we're going to do that here, and I'm just trying to think of an efficient way. I don't want to redo the whole board each time. So actually, we should just start from any point that has a value higher than 0. And so we can just ignore everything greater than or equal to 0. Or less than or equal to 0. Anything that has no boxes or less, we're just not going to mark. And then we're going to say distance board. And this is actually the scoreboard. Keep these names correct. This is why I don't like naming some of these sometimes, because it's the actual meaning of what you're doing sometimes changes. But this is now going to be the scoreboard. It's not going to be the distance. We're going to reduce the value by 1 each time. And flood fill, basically, it's not a flood fill. It's a... We're going to start from the high-valued ones, and every square they walk, they lose a score of 1. And they're all going to walk back to our target position. And then from the target position, we're going to have in each of the cells around us some normalized score. The highest value one will be the path to the one with the greatest number of boxes. Set position, comma, boxes. What is boxes returning in I-32? Now this is also going to be our starting set, though. Let open vec I.2 equal vec new open.pushback position. Now we should really do a flood fill operation here. I'm just going to do it inline for now because it's very specialized. And let's find out F2. What does F2 do? Well, apparently not. F2 appears to do nothing. But there's something wrong with the Rust plugin for Visual Code. Like, we have the RLS, and it basically never works for us. It worked only when we weren't doing projects and stuff. The moment we started doing projects, it got confused, and so it's never worked. And it's really kind of surprising, because, I mean, we're using the default setup and layout for a project, so it's probably something very simple that's causing it to fail, but we haven't figured out what that is yet. And so we have basically no plugin support. No plugin support whatsoever for Visual Code and Rust at the moment. We don't have... It just doesn't work. And that's why I always go to command line. It was really nice for the time we did have it. But then when we went up to the project setup, it just started failing on us. And it kind of sucks. There's not much I can do about it, though. I don't want to get detoured to fix the RLS plugin for Visual Code and figure out what it is. Alright, well, let's just do this the inefficient way first of all. We're going to do a while loop. While open dot size, count. How do you get the length of a vector? Start up Zeal. No, I don't want to download it. Leave me alone. Rust vec. Len. Send this fast. Is there an is empty thing? I don't know. So while it's not empty, we're going to start doing a flood fill. So we just pick the top one off, and is there a pop operation? I'll log Vic. Empty, thank you. Good, I don't have to look it up. Let position equal open.pop. Now, I've not sorted this list at all, and like I say, this is a super inefficient way to do a flood fill. There's a way if you want to sort the open list, you should always sort them from, well, it depends what you're doing. We should be sorting ours from the highest score down to the lowest score. And cries, that won't actually work though, I think. Or does it because we're modifying pop inside there, or maybe will it actually work? Can I modify the list inside there? Can I add stuff back into it? Let's find out. Well, that's weird. Usually this type of stuff fails on us. That's why we try the brain dead way, because we're going to push it back on there. Okay, so again, I'm not going to sort it first of all, because this will work without the sorting. It's just inefficient, because what happens if you happen to have the lowest numbered item in the list first, we're going to fill the whole board based on the lowest number, and then you're going to hit a higher number and fill the whole board again. Then you're going to hit a higher number and fill the whole board again. So it's inefficient, but we can worry about sorting later. And it won't be a big step, but let's put a to do there. To do sort open list. Actually should be a priority list. Is the binary heap a crate, or is it part of the standard crates available on Coding Game? If it's as... Alright, so we can probably change it later. Let's just use the vector for now, so I don't have to do that, and we'll just do this in. So position 10, pointer. And now we're going to check the 4 directions. And we're going to do this the most efficient way possible. We're going to do score equals disboard dot get, I think. What do I call it? Get. Position. This will be the score at the current position. And so the next score, so we'll call it current score. I'll try to start giving longer names so this is clear. Next score equals current score minus 1. So this is the score of the next one. And then for each of the valid positions, and I always get this wrong. 4 off in and what do we say for I.2? At, yeah. 1, 0 at minus 1, 0. This is probably super inefficient. We should have this list somewhere else. But, I mean, it's hard to say, because in an optimized mode, if we actually had release mode, this would probably be free. But in debug mode, this might actually cost something, so we'll probably have to come back to this later. And I think I have to do something like this and offset or something like that. In the I.2, I thought we had a bunch of default ones here. We could implement traits. Let's see. We did those traits in... Okay, yeah. Coming to Coding Game in 2020. The end stuff's a bit of annoying, but once you get used to it, I guess. Where did I have the other floating point stuff? That was all the floating point stuff we did in Botters, I think. I just need an example of points. I don't remember how I implemented them. So we're going to implement these points, and I'm going to slowly build up this library, as long as we remember what the last game was. So we can implement add point I point 2 for I point 2, and the output equals I point 2, and we have I point 2. And this does the add, and we should also do a subtract sub. So in our strategy, we can usually say let test position equal position plus offset. Then if scoreboard.is valid. Do I have an is valid? I do. I have an is valid here somewhere. Hello, is valid? Yeah, is valid. Now this is one of the main reasons for allowing negatives and stuff, because if you don't allow, if your point 2 is using use size and stuff, these operations become invalid really quickly because they're going to overflow. So it's a lot easier to just say, well, just let these ones have negatives and then test the position if it's valid. And we can actually just test it here right away. And scoreboard dot. And actually, I think I have a getter here that does a default. Get def. Yeah, let's just do get def. That's easier. If scoreboard.getDef test position. You can tell we used this before in Tron, how we did it. Get def. And we're going to do I32 min. No, what do we want to do? We want to do the get diff. Hey to all the new people watching. Welcome to the show. We're doing, what are we doing? Doing a thing called Hypersonic, which is a Bomberman. We're doing a Bomberman game. Our bot is stupid right now, but that's okay. But you can see the other Bomberman thing. We play Bomberman. Let's zoom this in a bit because we don't need to see those buttons. And we're writing a Bomberman bot right now. Hopefully you all see that. I'll just give you a few seconds to see what we're hosting. So we're writing the bot for this right now. Currently we're thinking of the strategy. We're still in something called Wood League, which basically means we're playing with the rules of the game. And right now what I'm doing is I'm doing a flood fill to find the place with the most boxes closest to where I am now. Our own bombs still don't kill us, so we should be okay. Opponent bombs kill us, but we can probably make it to the Wood League without that. Alright, so if the scoreboard is greater than the one that exists there, now how do I exclude spots from the flood fill? Because this is going to go right through the walls, which is not an issue. We'll just check that later. If it happens to be in a wall, then... Oh wait, we can't do get def then though, because if it's a minimum... No, we'll do maximum if it's a maximum. If it's not valid, it's going to give the maximum. So if the scoreboard is less than next score, then we do scoreboard set test position comma next score, and we add it to the list. Open.push we don't have a test position. Position plus offset. I'm going to push the test position. So what we're doing now is this fill thing. Is we filled the board. We started from all of these, all of the actual good crate positions. We pushed them all on. These are all good value crates are. And this is way too many in this list. This is super totally unoptimized right now. But we're okay with that. And we're going to do through a flood fill. We know we should use a binary heap now. So what we're left with the end of this is, I don't know if there's an easy way to print this thing. What we're left here is, if it doesn't work, we can debug it. I can show you later. And this is actually what we're working with on the Leaf project now. I'm doing a bunch of graphics in Leaf so I can start visualizing these things. I want to start visualizing these things in Leaf so I can show people what these algorithms look like, Leaf being my own programming language. Because it's really hard to visualize, but imagine you have a grid of numbers right here, and what we've done is from all the places we calculated how many boxes you can reach from that position. In every step we subtracted 1 from the score, and we're going to go back to our position, and then we're going to look at our position, all the ones around it, and from that position there we can decide Well, we follow the one with the highest number. We go to the one with the highest number because that leads us to the best possible score. And for people that are wondering, if you don't know this flood fill thing, if you've done A* before, this type of flood filling is basically like infinite parallel A*. It's like the A* done from every position on the board at the same time. And it's a lot more efficient. Well, it would be more efficient if I use a binary heap. The where I'm doing it right now, yeah, you know, this could be super awful. Okay, so now we have these scores and we have the position on the board. And, alright, we really need to put this in a list. How do I do a constant vector of this stuff? Let's just do, let offsets equal, we'll just do it this way. Offsets. We're going to do the same thing again in offsets. And so what's our current score? The current board has to have, say, let best score equal scoreboard.get. And we're going to start with the position we're at. We're going to start with position, get position. This is the player's current position. Let best position equals current position. And this will basically mean if this would be the position, they don't move. If the current position they're on is the best one, they won't move. Otherwise, we're going to check all the positions around them for one that has a higher score. Let test position equal position plus offset. If scoreboard.get default test position. And now we're going to say minimum. Actually, we're going to say let score equal. Let score equal. And say minimum, because if it's off the board, it's of no score value to us. And sorry, my eye is itchy. If score is greater than best score, then we reassign best score to score and keep that position as well as the test position. And then our return value is, we have an I point to, so the return value is the best position. This says, move here, this is your best option right now. And then entry we've already dealt with. We can get rid of this. Let near box equal neat box. Neat box would be cool too. Equals 2. What do we call it? 2 good bomb. Okay, that sounds good. 2 good bomb. And state. So it has the same interface, which is helpful. Player.position. And to go through this code again once here. With the near box, if we are on the exact position it moves, we should bomb it. Otherwise, we're going to move. And we don't have any look ahead here. We're just going to keep waiting for it. And if we don't have a position, and to simplify this solution right here, we're just going to put a sum around this so we have the exact same syntax it had before. Now we can do a clear and cargo build, and we should be able to see this work if we don't have errors, which we will. Use of uncleared, so strategy has to import matrix. Use matrix star. No point in compiling as we have that working. Use standard ops add. Did I actually have to do that here? Use standard ops star. Alright, so we have point 2, I point 2, probably I point 2. I point 2. These are integer points. Scoreboard, I already screwed that up. See, I call it scoreboard and I put disboard somewhere. Where did I put disboard? Scoreboard. Associate item not found in I-32. Alright, what was the minimum for it? Standard I-32 has a min. We have to use a constants library or something, though. Oh yeah, standard I-32. Okay, we'll do that. I don't understand why I have to do that, but I'm going to do that. So Visual Code decided to stop responding to my keystrokes for a second. I also have to use it. How can I use it so that actual syntax works? I want to import something. What do I import so that I can actually do standard I32 min? What does this import actually have to be? You know what I'm saying? I want to actually say, I want to use this library, but I don't want to import it. Just use standard? Okay. I don't think I've ever done that before. Okay, G94. Word. Push back, I guess that's not. It's push. You can tell I do C++ programming. Cannot assign twice to. Oh yeah, okay. I'm gonna have to make these mutables mutts. Some mutts here we need to have. Cannot. Boy, I forgot to declare all these mutable. Alright, it compiled. Now it's the moment of truth. I don't like polluting my namespace too much, but I guess that would also work. Let's see if I do anything. Uh-oh. Yeah, now we have to figure out where we screwed up. Usually there's a file without a line feed at the end of it, like right here. Our bundler doesn't like files without line feeds in them. As you can tell. We aren't dropping a bomb. I forgot to check if we can actually move in the check. If we can't move to the target spot, we shouldn't consider it either. Okay, that makes perfect sense. And alright, well, let's let it run. So I did that, I screwed that up. And that's in this best box here, this scoring here. We should actually check if you can't even move to it, let cell equal game board, where's that? State.grid.get def test position, and we're going to say cell type wall. You can't walk into a wall by default. If cell does not equal cell type dot empty, then we continue. The reason we continue is we don't want to scan into empty areas. We have to scan through just valid areas of the board. Oh yeah, okay, bombs count as well as 2. Yeah, okay, I have to change my scoring too, that obviously boxes can't go through walls as well. But I think I have that. That's why I have L cell type empty. I'm putting the bombs on the grid as well. So actually, do I put the bombs in the grid? No, I don't. But that's okay. We'll optimize that later. What we have to do is entry here. We have to somehow say to do place bombs on grid. Actually, that's probably okay. Let's do a special case. If entity type, we're going to add them right away, type equals entity type bomb. We do state.grid.set. I point to at x comma y. Cell type. We're going to need to have a bomb here. Now these are exclusive. A bomb is going to be an empty space otherwise, but they effectively work as a wall, which simplifies things for us. Bomb. And this box is probably a bad idea to call a box because it overrides that. Now the next thing we have to do in strategy here is this boxes within range thing. We have to change this that there has to be an empty cell type. Yeah, guys, I just want to get the basic one working first. There's things... Why would you mark them not as walls? I intend to do a simulation later so I can walk through, find the best position, and then walk through. And every stage that'll change, so it could change. And each step in the simulation, then you just recalculate the best move. Which is a little bit weird, but it might work. Okay. Now, we actually have to change this thing here. And this box is within range now. We have to consider that the spaces are empty. And so we have to do this in 4 ways. So for... Wow, there's got to be a way to do this easier. The bomb has a range of 3, so we have this positions thing again. Can I make this global? Shit, how do I do this globally? I want like a global array constant. I know I did this before. Let's get that working first. Const offsets. I hate the fact these are supposed to be capital. This is actually a bad naming convention. There's absolutely no reason why things should have to be capitals, but otherwise we get way too many warnings in our output, so that's the only reason I do it. And this is a vec of I point to offsets. Let's do that. That is what you mean, I think. Yeah. I just want something global. Can I just do that? No, we just do... Can I just do global? I don't even know how this works. I just want this. Does this work? I think I've done this before. Offsets. Let's try that. Now, this is exactly the reason why I don't like conventions that say constants and stuff should be capital, because whether this is a constant or not should not change the use cases. And I did this in Tron. Yeah, Petrus, okay. Depth 7. Depth 7 is going to be pretty hard for us to get to. I'm going to see how I did this in Tron for a second. I know I had global things. Right here, I had statics. That's how I did it. How did that work? Static offsets. Oh, come on. I hate this stupid thing. And I point to... I'm going to cut that off and put it back down. Oh, I can do... Oh, come on. Without the function calls, you serious? Oh, come on. You mean I seriously can't create a static that has function calls? Like, this is, like, stupid. I'll do that. That's lame. Yeah, no code before main. I know it's their mantra, but it's just not helpful. You can actually deduce from here. They have a borrow checker, so they actually have the complete pathway for code generation. Their compiler must know that those function calls to act don't have side effects or don't actually do code. So yeah, Petrocell, I was actually thinking about that too. The scoring is just simulate, and just as long as you're scoring good, and just I'm gonna have the exact same thing in my simulation. If I die, I just kill off that path. But what I want to do is do this way first, so I can figure out, do I have a destination? At least walk to that destination, but the simulation might just be good enough on its own. But we'll figure that one out. Now I have to do capitals, offsets. Can I like mark it unsafe? Like, is it possible to initialize a static unsafely with code? I'd be fine with that as a workaround. So, if they haven't figured out the safe version, that's fine. If I can just mark it unsafe, I'd be fine. Work fine as well. I'd be totally fine with that. Just say, look, there's no safe way to do it. I'm like, fine. I'll just mark it unsafe, and I'll call these functions. So now I'm going to say for and off in offsets. What's wrong with that? Why is that red? Yeah, I don't know if they have it offset static. What's wrong with my offsets now? Why is my offsets marked in red? Why are you marked in red? The hell? Who's marking this in red? Aha! That's what's marking in red. Well, red looks like an error. Yeah, that would definitely do it though. Okay. For I in 0 ... bomb range. Okay, so what we have here now is we can get rid of this. We want to walk from each of these ones, and how do I do this? We want to walk from each bomb towards the current position. Bomb, bomb, box, box. So I don't want to iterate the offsets. I just want to do. What I'm trying to do now is I'm trying to walk from each box towards this position here, and as long as there's nothing in the way, then I can do it. I can get to the correct location. And there's only one location it can possibly go. So we could actually say if entity.position.y does not equal 2.y and entity.position.x does not equal 2.x, then we can continue because we know this is not a box. Then we'll just do two algorithms here. If, let's say, let diff equal entity.position. Now we'll do 2 minus entity.position. And actually, let's make a direction function. Public function dir2 and self to I point 2. Reknakas, we are doing the flood fill right now. This is exactly what we're doing. We're setting up the flood fill algorithm to actually score all the skills and just walk towards them. And we're hoping that gets us far enough. And is there a sign function? Let off equal 2 minus self. Sine. I want sine of off dot x. Y. Sine of off dot y. Does this actually work? Is there a sine function? Rust sine. Now somebody recommended Zeal for this, and oh, you don't like the backwards fill. Okay, well I'm doing the backwards fill. Somebody recommended the Zeal tool to me, and I know it's an older version, but I'm actually not liking it, so I'm going to just keep doing the web searches for now, Rust. And I want to have a sine function. How do I get the sine of an integer? Rust sine of value. Anybody know how to do a sine function? I know how to do one, but is there one we can do? Function sine, there must be one. Signum? Is that what it wants? Let's check it out. Probably. It sounds like what I want. Well, maybe it's the F32, but I want. Let's see what it does in F32. That'll work. Is there one for I32 as well? I32 has a signum. Yeah, that's what I want. Signum. So this would be off.x.signum. So this direction 2 function, it just says what's the direction, and this is a normalized direction. Like this is like integer normalized from one point to the other. Which direction do you have to walk to get there? And so what I have here is entity.position.direction2. And we can do this for I in 0 dot bomb range. And we're going to create another helper function here. We're going to create a mul function, because mul is fun. Implement mul I32 for I.2. The output's an I.2. Mul self scalar I32 self.x times s times s. Okay, we got that. And then what do we say? We say let test position equal entity.position plus diff times I. Good. This tells us the position we have to have. If test position, I want an equals equals. How do I do this? Okay, we're going to do this. I.2. We need to do an equals. How do we do that? Partial equality? Is that what we're looking for? Partial equality. Partial equality. Equals and not equals. Well, do I have to implement not equals? Or does that mean there's a default? Only equals. That's good enough. I don't have to implement it? This will be enough? Okay, good. That'll be enough. There must be a default for it. If test position equals 2, then we can do count plus equals 1, and break. We also have to test the board. We're going to do if state.grid.getDef test position standard I30, no, cell type, let's just say wall, does not equal cell type empty, we break. So the moment we hit a wall, we don't do it. And again, this function here is just walking from each of the boxes towards us to count how many there are, see if it's there. I don't know if it's very efficient, but it'll work. 77 entry. If entity type, I don't know why that was returning a value. It seemed to not care about it. G21. I.2 probably. This is an I.2 22. 0.2 self, fine, that's fine. Trait bound iters not satisfied. Okay, because that's just supposed to be offsets then, I guess. Strategy. Probably just offsets. Let's figure this one out. 77, that's really weird. Alright, well, let's do it this way. So we're going to change this a bit. We're going to say let entity equal entity states.push entity. If entity dot what? That's what we wanted there. Offset's the same thing. Strategy, we need to go to 130, 130. Don't need the and. Alright, it worked. Let's see if something actually works. I don't want to have to do testing yet. Let's see what our little bot does now. Uh-oh. Uh-oh. Doesn't do a lot. That's not a good sign. We might have to implement a test case. Alright, one more test before the test. Let's logically say it does something. Well, it did something more before. Time to implement some tests, because we have a big unpointed point. We have a whole bunch of crap that might possibly not work. So we're going to have to start doing some tests. And this is a good part of the show, to show how these tests work. And I've completely forgotten how tests work. Let me open one of my other ones. So we create a test directory. And I think we did this in tic-tac-toe. We had tests. We had a state test. Let's copy a bit of this. Hypersonic, and we want to go up and create a folder called tests. And we're going to create an I-point test, I.2 RS. Okay, extern create Hypersonic. Is it? Alright, great. Well, where do I put this configure test then? I'll get rid of that then. You mean I don't need this? I thought I needed this. I guess I don't need this. Then we'll get rid of it. Aha! Oh, so that was like if I'm doing a test outside of the test directory. I thought I copied an insert over, but don't make a big deal. Insert test. FN, let's just do a basic add. Let's just do some basics here. Key equal I.2 at 4,7. Assert equal I.2 at whatever q plus I point 2 at 3, 5. Let's just do this. Let's just do basics. We're just looking for basic things here. This should be 7, 12. And we're going to run the test here. Cargo test. Uh-oh. We got to import some stuff. Use, probably Hypersonic. I point 2 start. Alright, one test passed. Wonderful, we got a test pass, since we have a basic test. So let's just run through and test all of these first. Direction 2 is another important one. Let q equal I point 2. Well, I'll just do the same one. 4, that's new, no. 2, 3. Assert equals I point 2 at, we're going to say 1, 0. Q plus, no, Q dot direction 2, I point 2 at, what does it matter what this is? 3. Now, I still haven't figured out why some of my code compiles twice. We compile twice, and we appear to run we run a whole bunch of crap here. I don't know why it runs all of the stuff. There must be a way to get cargo tested. Just run the test directory, because that would speed it up a little bit. Oh, yeah. So what I want is, I'd love to have some way just to run the one directory. And let's clean up these warnings as well, because they're getting to be annoying. Unused macro. I thought I cleaned this up. That was something I wanted to put in the code. Unused macros. Entry, this is line 8. Let's clean this up. So you can see it's compiling the stuff twice, which is really annoying. Entry tree 55. Don't need that one. 63. We don't know what these are yet, so we'll leave them out. So you can see everything's compiling twice. Alright, that's a bit better, a bit slower there. Okay. And I know I have a file for that somewhere. Evening Rust. Why is it, what the hell is it sorted by? README, cheat sheet. Tests. Just test directory. Alright, so we can close Tron over here as well. So now we're still trying to figure out, let's do a couple of these just to make sure there's something there. Let's test 0, -1 here. This is at 2, and this is at 0. And if it's completely in the wrong place, direction 2, if it's directly at 2, 3, it'll be 0. And you might actually have a 1, 1, 1, -1. It's really weird. -1, 1. It's not really going to be helpful for us. The direction 2 is kind of broken in this situation, but we've already considered that in the strategy that if one of them isn't there, then we continue this. So the direction 2 is really only well defined. So I'm just going to ignore that. Direction 2 is not well defined if it's not in the right place. Or I mean, if it doesn't have a proper directory. Okay. So direction 2 seems to work. So I think this probably works. Let's just do a multiple. Let's do a simple one here. Equals I point 2 at 8, 14 q times 2. So the I point appears to be working. So what's going to be broken now? Do we have to test the strategy? Now the strategy doesn't actually have public code. This is where it gets really annoying. And to actually start testing the rest of this, we're actually going to have to start setting up a board, which is a pain in the ass. But we can actually do this. So the state strategy actually takes a state. Alright, let's do that. Let's set up state. We don't need this thing here. Just copy one of these so I have the syntax. Tests. You know, actually not clear on this. Is going to be a strategy test, I think. Not a state test. RS. Then we can close off the I point test, and we're going to have... The first one I want to test is boxes within range. Boxes within range. We're going to have to create a state. So we're going to do let mut state equals state new. And we have to give it a size. Let's just do 10 by 10. It should be fine. And we have to modify that state. How do we do it in the entry? State.grid.set. State.grid.set. I point to at. Let's get this way. So we're going to create a box at, let's say, 5, 0. Cell type box. And we'll create a couple of these. We'll create one at 6, 2 as well, and one at 3, 3. So what we now want to do is we want to test these things, assert equals to whatever we have. If I put a person at, now visualize with me, I put somebody here at 5, 2, there should be 2 boxes within range. If I do strategy boxes within range, and state, and what do I have to pass it a position? I point to at 5, 2. Those are all within range. Let's see if this works. Oh, we got weird stuff not working. Gotta import the state, that would help. We probably don't even need to use that. Incorrect closed delimiter, there we go. No, it's not liking us. I gotta import that as well. Use hypers. No, I can do something like this. Can I do this? Let's find out. That'd be nice. Probably not gonna let me do that though, is it? Aw, that's no fun. Oh, you can't. One. So somebody's read my mind. I guess it probably only works with star renumerating things, but that's okay. State, it probably takes an I point position. Yeah. So what I just did apparently could work. Expected 0 parameters. What? Yeah, that'd be really nice. It'd help a lot. Boxes within range. Oh, I think I have to do this. Use. Yeah, this would be really helpful here if I could use the same import multiple times, because this is going to get really bulky, and that would really help in my lib statement too. Strategy. What, is that a problem? I want to do this now. Strategy. But that's not going to let me do that, is it? Unless I do... Let's do this then. Index is out of bounds. Well, that's probably a reason. That probably fails. And we're going to open up the other test because it complained about the thing I said. We probably don't need this thing here, so let's get rid of that. Fun! Or to get out of bounds. Cargo test. Thrust back trace equals 1. Let's figure it out. I haven't done that in a while. Where is it mad at me? It's mad in... Strategy RS9. Oh, I can click on that. Oh, yeah, because our state... our matrix isn't filled by default, which is actually quite silly. Let's do this. Let's. Q equal Q dot fill. Oh, I can't. I don't have a default. So I have to fill it. Alright, so this is not the cleanest way to write this code. We're going to have to do a state.fill cell type empty. Because I can't, unless I pass it into new, it's not clear. I should probably pass it into new what the default is. State.grid.fill. Where do you get mad now? Got mad there. Why? That doesn't seem like a good place to get mad at. How can it fail there? How the hell can the assert fail? Oh wait, that's the test failing. Yeah, I return 0, but why on earth is this causing a... Oh, because the backtrace goes to that. I understand, I think. You don't need a backtrace 15, so it returns 0. Okay, so this is where we've identified the point which we're failing. Boxes within range is returning 0, which is no good. And so now we can start debugging that one. We have I.5, 2, which clearly should have identified this box and this box, but it didn't. And why did it not do that? So let's look at boxes within range. If it's a bomb, we say... I don't remember why we say that. Any what, but we don't have any bombs in there anyways. And oh well, we actually have to add boxes to the entities as well, which probably means, yeah, it probably means that we have a duplication here. State.entities. What do I do in the entry one? So I have a duplication here between entities push and grid set. That I should probably have a push entity function which actually sets up the grid as well. But I'm going to duplicate for now unless we see it. No, let's actually do it. We're going to say we'll make a function that adds the entity. Add entity. And it's going to take the entity, add mut-self entity self.entities.push entity. If entity.what equals, what is this thing? Entity is entity type bomb. Then we do self.grid.set entity.position cell type bomb. So we're going to add an entity here. Add the entity. We're going to do state.add entity. Entity. And how do I create an entity? It's hopefully not complicated. So what owner and position? Yeah, whatever. What entity type? Owner is 0. And position is, and this is where we want to put this position. And we're not adding a bomb, we're adding a box. Alright. Macro might be helpful here, but not even a macro, just like a function. Oh, what were those two? 6,2 and 3,3. We're adding those three. It's a bit of duplication. We just need to see this work once. Entity type. There's no entity type. Okay, game box. That's where I called it game box, yeah. Game box to avoid clear names. Alright, so we still have... Oh, well, we have an error. Well, I forgot to fill the damn grid again. Why did I do that? Not the clearest high-level code to write the tests in, but we'll be okay here. Oh, we found one now. Oh, wonderful. One. What did I do wrong? Let's get debugging. We should see 2 boxes here and debug. From end stop position. So 2 of these should show up. And it's not going to show me the output, is it? Oh, there it is. Alright, so 2 of them are there. Good, so this fails on a bomb range. Let's just check everything. Well, it's not getting that one. Put a tab here. What are we getting in here? Test position. What are we finding? Well, we should probably say what we're finding. I don't know why Rust is so slow to compile there. Six comma two, 6,2. Weird. Because it's not a cell type, so we always have to start at 1. Otherwise we'll drop off. Alright, so what's at these positions? Let's figure that out. The grid cell equal, well, I'll give it full names. Grid cell equals what's at this position is this is probably a debug one as well. What do we have here? Grid cell Debugging is so much fun, isn't it? Come on. So I don't like using long names. I use a long name and then I forget that I have to use I use a short name everywhere else. Empty. 5.1 is empty, and then found it. And 6.2 just doesn't run any tests. How does 6.2 not run a test? It finds it immediately. Well, what is the diff? There's something wrong with the diff still? Diff. -1, so that'll be 5.2. Something really weird here. So it's not iterating, like it's not checking. So it gets to here and it says from this point, 6.2, it knows which direction it's going. Oh, and that's the one that must break there. So let's see which ones are doing this. Print line found. And let's figure out why this is not finding my bombs. Come on. Found it. So the first one's not finding it. So let's verify this again. At 5.2, it should find us at 5.0. So it goes 1, it goes 2. Bomb rate, oh shit, yeah. Bomb range +1. Because these lists aren't inclusive. That would help. Alright, so that actually works. So let's get rid of that. Let's do a few more tests and verify that's actually working. Yeah, so range is 2, and so this way has to be an inclusive range. It only covers 2 cells. It says 3 in the game, but that's actually a lie because it's counting the cell it's on. So we say 2 away from the bomb. Right, so let's do another one. Assert, let's count something else. If we do 5.3... there's a bomb at 3.3, so this should find just 1 bomb now because it's too far away from the first one. Right, and one more test. If we put a thing at 6.0, 6.0 should also find 2 boxes, and very clearly 6.1 should find just 1 box. Alright, good. I think boxes within range is actually working. Was it working before, or did we actually fix it? Now I don't know anymore. I think we just got the item. So boxes within ranging I think is working. So now we have to go and test the next bit here, the Too Good Bomb. Oh wow, this is delightful. Too Good Bomb is the issue right now. What would be the best position to bomb? I don't know. We're just going to debug it. I don't think we have to do an actual test. We can just debug it. And we'll let it figure it out for ourselves. Too Good Bomb. We're going to do the same thing. Copy the same setup. Too Good Bomb. And we're going to do where position equals strategy. Too Good Bomb. And state. And where are we? Let's say we're at now. And where are we at? Let's just say we're right at the beginning here. I'm 0.2 at 0.0. E-print line. Where is the good bomb? It must be out. And I don't know why it's running it twice. This is bugging me. It's running it twice. Too good bomb. Why does it not show my output? Why was it showing my other output but not showing this output? Need to see output. There was a way. I had that in my cheat sheet, I think. Where's my cheat sheet? Right there. I don't know why it was showing the other ones, though, but wow, I haven't pushed that up in a while. I should probably push that up. It's in my cheat sheet. Why is it not in my recent ones? Whatever. I'll just open it again. No, not that. Oh, it was in the README. Ugh, no capture. Too good. I point 1,0. Okay, so that's obvious. No, that's actually correct. One comma 0 seems reasonable. That puts me in a decent spot. Alright, so if I'm way over here, if I'm closer to, say, 6,2 or something. Let's see what it says there. It should give me a different one. 5,2. So that appears to be working. So what isn't working in the actual game? I have a strange feeling that our bombing stuff is working here now. Let's just assert this. Assert equals. I didn't manually verify this, but it seems reasonable. 5,2 seems like a reasonable place to go. 5,2. Comma position. Let's close that test. Close the README. And we know in state now we had a add entity, so let's use that here. State dot add entity, and that takes care of the bomb. Sets itself, it's a bomb, so let's get rid of that. Near box, and it prints out ePrint line. Let's see what the game's actually doing. Near, and I'm going to say near box. Something weird happening here, so clear and cargo build. What is the game doing differently that our tests aren't doing? Because we're just sitting in the corner there. Oh, I must have fixed something because I suddenly won. Oh, I should actually track if I accidentally pick up an item, because that makes my range bigger. So we won. We won against this guy. But if we both die, I win. That's cool. So let's submit this. Let's see how well it does. Now, dying is going to be a big thing, as we know which way we want to get to, and the next step is going to be run the simulator. And this was, I think, Petrosil said, is that what our simulator is going to do is we're actually just going to do a walk of our move and emulate the moves, and we're going to score it that way. If we ever die, we evaluate that path very low, and edA-qa says this should be enough to get us out of the Wood League, at least. We'll see. Well, you jumped up pretty high pretty fast, so Again, this is probably just dealing with the basic things, the walls. They really just introduced the walls on this level. Let's see if we can deal with them. And it looks like it might be enough. And we might end up actually killing him. It might not be enough, though. Although, let's just watch the leaderboard. We're pretty high. So we're sitting here, we're going up. Yeah, that's probably enough. So our strategy so far is pretty good at finding a space we want to go to. What we don't consider right now is it safe to go there? And this is going to be the emulation, the next one. Basically, we're going to check for each move. Does it put it closest to our destination, and is it safe to go? Where safety is going to be the overriding factor. And what we're going to return is we're going to actually use an A-star here as well. And it's going to be a weird A-star. The A-star is going to have a temporal component. And, okay, items cut off explosion ratio. That's an added thing. We should be okay if we actually just ignore that. So we might not win enough here. We'll see. So the next step is we're going to do... The A-star is going to be temporal as well. And I have not done one of these before. Which really would mean every step we take, the board actually changes. So it's not like a typical grid in A-star where you say, look, the next state is a version of the state. The next state is going to be a complete board and position on that board. And so if Cry says he doesn't do that, I'm guessing Cry is just going from all the bombs. Is he out of range of them? So at any point, if the range is outside of it, he says it's unsafe. But you may end up... I don't know if you did an A-star. You might have accidentally done the A-star as well, right? I mean, I'm using the term A-star here because that's the logical thing I'm doing, but it's going to look very little like it. I'm trying to find a destination on the board, but I have a temporal component as well. So my heuristic is going to be, am I closer to my destination? But I'm going to exclude a lot of things. Anytime I hit a death zone, I'm going to say, look, that's the wrong path. It suddenly has a score minus infinity. Yeah, moderate scale. I know they do that, and I think... Yes, I know there's all these options. There's all these options to do it a quick way, the safe way. You have a lot of options. Cry's 8 loop iterations. You mean like 8 simulations, but are you just doing like, you mean like a depth first or a breadth first search? You're doing like 8 down, and I'm so reluctant to do the breadth first search from the other games we did, knowing in the Rust is that the level of search, you run out of time so fast. But we could very well do that. That might be the easiest option. Just do a breadth first search. We're still going to calculate where we want to go so we don't get stuck. That is, if there's 2 that have equal value, we're just going to say, well, let's get here, and then use a heuristic for where we place bombs. But the breadth first search is basically, you have... You actually have multiple options in it. You have 4 options. You have... I guess you actually have 10 options. And this is why breadth first search is actually, if you're doing it scoring based, you actually have 10 options in any given move. You can move to 5 different spots where we're sticking a 1, or you can bomb to 5 different spots. And so this is the depth. Each move has 10, and that explodes very quickly. And 10 to the 5th then is what, it's like 100. That's 100,000 moves to evaluate, and I'm fairly certain we're not going to do that. So we're going to have to prune that somehow, and that's why I'm suggesting the A-star to do the pruning. Unless you guys aren't doing the bombing, you're doing the bombing based on a heuristic. Now that could be another option. So you only have 5 based moves. What was I going to check here? I wanted to check, yeah, when you move. Alright, so we actually only have 6 options, because bomb places it on the current cell. So at each step we have 6 options. Stay where you are, do nothing, or bomb and move to the 1 of the 4. 5 options, depth 7. Just move, 4 options, and 1 option for bomb while standing. Yeah, that's another option, Petrocil, is we just do that. And 7 depth. So we can probably implement that one. Let's just evaluate that depth. And we can still look for the heuristics. So to avoid getting stuck in an area where nothing happens, we're still going to take the score we have now. We're still going to say where is the best position on the board. And so if we do the depth first search and we can use that to tweak the value and say, look, when there's multiple scores, the one closest to our target is worth more. And that helps us tweak the score, but the depth first search has probably helped enough. And Petrocil said that's actually sufficient. Okay, wow, that's interesting. That got you to legend. Then we'll just go that way. If you're saying the A star is not necessarily important, we're just doing a breadth first search, then okay. What the hell? The boss jumped! Do we really have to do that to get out of this league? I was hoping I could get out of this league without doing that, but yeah, we can probably do that now. That means we'd have to do the full simulation, though. Wow, you guys, I mean, it's a bit weird. I'm pushing the boss up. You're blaming me. I'm pushing the boss. No, I'm going to blame everybody else. We're pretty high here. We might be able to tweak this a little bit, because we're probably dying against that boss, yeah. Yeah, Petra, so that was my idea with the A-stars. The A-stars, the heuristic would basically be, I find my ideal spot, and that's what I'm doing now. Right now is what I'm doing is I'm finding a spot that has high value, and my idea was for A-stars, try and get to the high value. But optimistically, when searching, I'm just going to use that to tweak the scores. But every place in the breadth first search in the A-star is going to score it based on what grids I get as well. And so there's a chance that if I'm the guy pushing up the boss here, as soon as my battles run out, the boss might come back down. And we could sneak through, or we could do a simple tweak and probably just avoid dying in the boss. Just stay away. Just stay more away than him. Simulation gets a bit harder now because we have to track. Can we track the items that the enemy picks up? We're going to have to do that. We're going to have to know what enemies the enemy has. Yeah, Petrocil, so far we haven't written very much. I mean, the state stuff's going to change the same, so we don't have to rewrite anything. Our strategy's going to have to change, but I'm keeping it very focused to clear the state, and the actual simulation stuff is going to be very generic as well, such that the generic that will never need to be rewritten. You implement state each thing and go through, but you might need to tweak it for speed, and if we do it that way, might do that. So we're going to combine it. And again, we're trying to combine heuristics and searching because we know from other games that we have performance issues. And we're sitting here at 4 in Wood League still. Yeah, who knows where it would. Man, can we tweak this to get out of here first? Because if I had to do simulation here, we know our simulation is not complete. Because our simulation is not complete because of the fact we're not hurt by our own bombs, which is going to make it difficult to, which is actually in this mode. Let's see what happens. Let's read this a little bit. What happens? How do we could start the simulation, or does anybody have an idea how we could quickly tweak this just to get a few more points here and stay away from the enemy? Yeah, that's probably a wise idea. Check a few matches we lost. The ones where you lost consistently, like right here. Reknakas, I don't track explosions at all right now. So Reknakas, I don't avoid explosions. That's a really significant thing. Also, I just get stuck. That's my problem. How the hell can I get stuck? Alright, so this is the reason why. This would help enough. Just knowing why I get stuck. So like I say, Reknakas, I don't have to worry about explosions at all because I don't consider them right now. I am not avoiding death. I'm just walking around bombing stuff, assuming I'm okay. Again, Alright, so what the hell is right there? How could I possibly get stuck? This is weird. What logic would I have to getting stuck? I don't place the items on the board yet. So these are just basically ignored. I shouldn't be seeing these at all. Would you give me 2 points here, 2 points here, and 2 points here? 2, 1, 0, minus 1. 2, 1, 0, minus 1. So they both have a better value. Unless one of those is 1 and I'm counting wrong. Wait. 2, 1, 0, minus 1. 2, 1, 0, minus... Why? Okay. Stuck. Why am I getting stuck? Fishy, fishy, fishy. Do I properly clear the board between them? Well, if I did something horribly wrong, I'd probably I fill the grid with empty each time. And how could that possibly have... Well, we're going to debug this one. Now this is what I did in one of the other games. If we output the game board, we can actually simulate from the beginning. Let's see, we go here, we place the bomb, that's fine. We walk here, that's the next spot. We keep trying to bomb it. Then we bomb, we walk there. The items we just completely don't consider. We're trying to move into the box. Ah, okay, Reknax, I understand what you said, yeah. Because the items are cutting off the explosion, but... Yeah, okay, I understand what you're saying. Yeah, that might cut us a few. I'm thinking getting stuck here is the biggest issue, is that 11,9, why am I trying to move into this box? So if I'm at 11, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. I'll zoom in. I'm trying to move onto the box, it looks like. And that's why I'm not moving, because it thinks that's the box is the best position. But why is it not excluded that box? What's special about this grid that I've suddenly excluded that box? Okay, strategy. We say too good bomb. All the boxes within range, so I think that's good there. Just debug mode. Where's the debug mode here? Okay, on. 11,10, that's fine. I got that right. Alright, so 11,10. We're trying to go to 11,9. We have to figure out why. Why are we trying to go to 11,9? Let's dump out the board first of all, so at least we can see that we have a correct view of the board. edump. Let's just do an edump and self. And this does nothing. An edump. And what are we going to do? For each for y in 0 dot dot self dot size dot y, or x in 0 dot dot self dot size dot x. E print line. E print match self dot grid dot get to x comma y cell type bomb mark it with a star, I guess. Cell type box. Oh, we're just marked it with an X for no. What was it? 0 for now. We know there's items in there, but we don't have that marked yet. Cell type wall, and this is an X. Cell type empty, and this is a dot, I guess. Entry edump. Well, I just want to make sure that we're actually getting something correct here. State.edump. Right. Not that I have a wrong view of the board, because that would obviously screw up everything. No! I pressed the wrong button! Shit. Does he get stuck here as well, though? Alright, this one's also stuck, so that's fun. Okay, so I move 9,9. I want to go there. Do I have the correct view of the board? I do. It's a wall and a wall. So why am I trying to move to 9,9? That screws me up. Okay. So that's clearly the strategy is something wrong in the strategy. So in the strategy, what do we have? We first timed all the boxes within range and set that. So these boxes are clearly not on walls. We should be okay with that. And we try to go down now. We say for edge open position, if it's a wall, if the cell is not empty, we continue. If the score get def is less than this SOAR, and it's a maximum, Eric Nagas, I'm not sure the coordinates would be wrong, because we wouldn't get that high, right? Because we're like at 4, so that's why I say I don't think there's something fundamentally wrong, but there must be, and well, let's do that. We can do that in the edump too. let us equal self.findPlayer. Great, so Christ had the same bug, so I just try to figure out what the bug is now. Self.myId. Well, I'm not assuming that, so that shouldn't be the issue. Position equals us.position. ePrint. Let's put a star for us. Else. Print something else. We'll just quickly verify that we're in the right position. Oh, I pressed the wrong button again. Damn it, I have to change it so I can't press the wrong button. We are on the map, though. You can see us walking through the map. So let's go back to last battles and find one we lost. This one here. And then we're going to switch to options here. And go to manual. Going to manual is basically if I press the wrong button, we'll still be okay. It won't overwrite it. Alright, so we pause that now. I'm in the right position here. So what we're going to have to debug somehow is, we could actually parse this back in. I don't really want to. There's a box. We ignore the items, that's fine. The items don't show up in our map, and that's fine. They shouldn't. Indecision. It shouldn't be a problem if the score is the same on both sides, because we just prefer one side over the other anyways because of the way our for loop works. So now we're going to debug that for loop. That really sucks. Let's just do this. ePrint line. Score. Equals whatever this is. Test position, comma, score. Let's figure out what these scores are. And we're going to compare it to best score. Best. Let's figure out what the issue is. I somehow think our current position somehow has too high of a score. Again, so I hit the wrong button again, but it's okay because I'm in manual mode. That prevents it from generating a new output. Alright, there we go. How did my current position get a 0? This is the issue. How did I get 0 on my current position? Alright, so I have two zeros here. So 12, 10 is minus 1. And 10, 10 is 0. But this is also 0. How did that happen? How on earth did that happen? If 12, 10 is minus 1, how on earth did this get to be 0? One of these would have to have been a 1. (11, 9) is a... No! 11, 9 cannot be a 1. No. How is 11, 9 getting to be a 1? What am I missing? What am I screwing up here? Oh! Because my seed values, I don't check if the original position is acceptable. Should that be done within boxes within range? Hard to say what should be done here or boxes within range. Boxes within range. We can simply shift the order of this. So it won't count it if it's on that box. That should be sufficient. Now let's try it again. Just avoid getting... Yeah, that makes us win it. Very good. That looks much better. So this guy gets stuck too. I'm happy to see that. You love it when you see this. People are making very similar mistakes. You get stuck in a scoring loop. And mine shouldn't have a scoring loop. The reason we had a scoring loop is because we're putting scores in a position we couldn't get to. Not that we have a loop. We just couldn't get there. So let's submit this one. We're writing out a bunch of debug, but we should be okay. So we didn't get above 4. And just winning 2 more battles. You see, winning just a few more battles should get us higher in the ranks. And that lets us win a lot more, so we have no losing battles there at all. Let's check the leaderboard, where we are. Oh, we got up to 8 with like 0% battles complete. Wow, that makes a huge difference. So that was a tiny little bug. And the tiny little bug makes a huge difference. And it looks like we'll get out of this league fairly easily now. I imagine we still lose in some cases because we have no simulation. We're not protecting ourselves at all, but again, it's Wood League. We're just trying to deal with walls, and so we just deal with walls here. And I'm going to do for the next one... breadth first search is probably enough. Where did I go? Hello? I disappeared. What happened? Did I drop somehow? Hey, somebody beat me. No. I can't drop that far down. I was doing so well. No, I'm sad. No, I'm not doing so well. Alright. So apparently breadth first search will get us far enough, and Petrocell confirms he just tested 5 options instead of 6, which is, not going to be a huge difference. And we might be okay with that. I'm concerned about the depth, 6 to the power of 7, he said. That's still quite high. But we're going to have to get the simulation next. And the simulation... And so the breadth first search basically just tests everything. And the breadth first search means test all the possible conditions. And what we wait. Okay, so we made it to the next league. We should be fine. Let's just see how high our score gets. Why I said A star, and I'm going to do like a temporal A star too, is the reason I say that is it prunes a lot of stuff. We have the destination we want to get to. We know the one we think is worth a lot, but that's heuristics. Yeah, so that's. Right now we're using heuristics where we want to go, and the A star is based on heuristics saying, well, this is where we want to go. And the danger with heuristics is that it'll keep us safe, we can do it, and we'll get points for it, but the danger with heuristics is that we miss opportunities. We don't know if something along the way is actually a better move. Now the problem with not using heuristics, though, of course, is that to a depth of 7 or 8, you're not really thinking that far in the future. But Kry's made it all the way up to gold, and Petrocell made it up to legend with basically that. So it doesn't look like you have to think far in the future. And so either way should work. Neither of them are necessarily easier to do. Our biggest issue is going to be with how we replicate the state, because regardless of how we do it, each step we have to replicate the state. So Petrosil says, for the most part of it, it only had 4 options. I only planted bombs, advanced that branch if I had boxes in its range. Yeah, and this is, again, this is also a limitation here, is that in Petrosil's model, if you actually have that logic in there, what you're missing out on branches of the game are the ones where you kill other players. But if everybody else is playing safe, that's probably okay, because you're never going to kill them anyways. But if somebody, this is where it gets weird, is that, and this is why a lot of games end up having like some sort of searching, breadth first, A-star, and heuristics involved, because there's just too many details to consider. There's so many options. You have to be able to prune somehow. And simply ignoring the enemies is a good way to prune. Keep yourself safe and take opportunistic box bombing. And chances are, and this is where it gets really interesting, there's a good chance that if everybody has that type of approach, some bot could come in that just goes around killing people, like planting bombs just to trap them, and it might do quite well, but that's a completely different strategy. But it's going to have the same basic core. And Petrosil doesn't even have the enemies in the game. Okay. Yeah, that's rather interesting. Just ignore it. Oh, so, and Kryze is confirming that the Gold League does actually have people that try to kill you. So there are people with both strategies. Okay, interesting. That's good to know. And again, here's another opportunity for heuristic. If you had both strategies, could you switch between them? And if you had a full depth search, and a full depth search basically is if you considered every single option, and those are there's 6 options per move. If you considered that throughout the depth, you'd include the killing ones, and Petrosil is pruning the ones that might kill, so he's got a lot of that removed off. And the reason you prune is because 6 options, even to a depth of 8, is really, it's going to be too much. Again, because we're running in debug mode. Now, what's going to be curious this year is they want to try, they mention a lot of times they want to enable debug mode, but what's going to happen is that if you suddenly switch all of these languages to release mode, the dynamics of the leaderboard completely change across all of the language. And so that's going to, I think that might be the reason why they're dragging their feet, because you might be able to introduce release mode on new games and then one at a time for old games, but if you did it across the board, the leaderboard would really good too. Yeah, Rick Naka's Monte Carlo is another option. And the one I talked about last time with the tic-tac-toe is the fractal AI, which is a variant of Monte Carlo, would also work well here because we have a score and we know what the score is and we can track the score. And that one has a fixed number of walkers, and it basically does pruning and shifts them over to the ones with a higher score and keeps considering them. And it lets you go through a much further depth. So Monte Carlo lets go through a much, much further depth. Except with that, is ideally what you'd have is you'd have a breadth first search to keep you safe. So a certain depth, you're going to say, look, prune off all the really unsafe ones. And then for all the ones that remain open, do a Monte Carlo starting from those positions to see which one is the highest value. And so basically play it safe, and of all the safe positions, find the one that represents the potentially highest value. And I think that would work really well. But in debug mode, I don't care what language you have, in debug mode there's just no way you're going to evaluate that a lot, because Monte Carlo requires a ridiculous number of iterations to have some value. And we found that in tic-tac-toe. But it would work, and the fractal AI would actually work here, but that still requires quite a few iterations. And I'm really concerned with right now is that the way we've represented the state with the matrix, it's going to be extremely costly to duplicate this. Our cloning operation might be the most costly part of this whole thing. So we've advanced to the next league. In 2 minutes, I'm just going to be talking for now. Let's save the game. Let's save the state. Git status. We added a lot of files. Git add source.matrix tests. Whoops. Out of Wood League. I have nowhere to push that to, so I won't push it. And why did I suddenly appear chat in there? Oh, it's the other ones. So we're going up there. Want some pool. Cries, what do you mean by pool? So now I could try the standing still strategy because most other people just get themselves killed. Cries, what I actually tried on the Code for Life, which I can actually do here, is a really good option to reuse objects, is instead of cloning the state and modifying it, what you can do is each turn comes with an undo operation, and so that as you backtrack out, you apply the undo instead of just using clones, and that greatly reduces the amount of operations you have to do. And that's a great option. So, because typically when you clone these boards, you don't need a full clone, you just need a small clone. And the pool, but the pool is still a great idea for that. In the one place right here where I do, where's that? In the strategy where I'm doing this board here, is you can actually pass this around or some pool. I'm not sure how to do that, the pool. Just to avoid the allocation, because you have to fill this every time here. If you just reuse the same memory, that would also help too. The undo and reusing the same memory might make it cost effective. And again, with breadth first search, that might buy you one additional level, which is, I mean, extremely helpful, but not a lot. And the same thing with like this, the good bomb and stuff. Like, there's a lot of stuff you don't have to do, but the actual iteration at each level, what's safe, the simulation, can probably just be undone. Yeah, I can pass the mutable references in. It's really annoying. Or I can just use a unsafe global. I've done that in other ones, and I can probably do it here as well. Just use an unsafe global to avoid polluting the arguments. Yay, I'm in the next league! Woohoo! 4 players. Bronze League. So, where do I sit in Bronze League? Come on. Just submit it and we'll find out. I assume I'm going to die a lot here. Wow, I never do well here. I tie. So we all... we all die by our own bomb. Yeah, okay. This is... I forgot we died by our own bomb, so we're not going to last very long at all. Yeah, we're going to do exactly that. We're going to skip over this league and just not die. So let's get rid of all this, and let's see if this actually works. Print line. Move, and player.position.x, player.position.y. But destroying one box is very dangerous because that means I have to actually move out of the way. So I can just move up one and do... let's just see where this gets with this one. Play it once. Alright, so we don't actually have to beat the boss, because if there's not other people dying, they can end up killing us. They're helping us. So I'm curious as to where just this gets to now. This is like... So we have mainly people that just made it out of the other league, and you don't deal with your own bomb yet. And so cheap... These are what I call... These are degenerate strategies, right? And when we had the last competition, Botters of the Galaxy... A lot of people had for a while degenerate strategies. There were some things you could do where it was just like really, really trivial. And so degenerate strategies work to a certain point, but if you can find a weakness, Borders of the Galaxy had some weaknesses that some of the degenerate strategies actually perform quite well. And I mean, it's great that people find them, but alright, let's see where we make it up to first before we destroy one box. Because we can make an assumption about the board, which seems to hold true, is that from the starting position, the two positions beside us appear to always be free, so all we have to do is walk basically right or left one, place a bomb, then walk out of the way, and that would be the one box. If we get high enough. If we don't get high enough anymore, then we'll actually have to do the correct strategy here. But we're still moving up, and let's see what this is. So I think we know what our strategy is. I don't know if I'm going to do it tonight. I've been on for a while now. I'm trying to think. I'm getting kind of tired too. Too much time in the sun, eating food in the beer garden. You know, that addles the mind a little bit. Tomorrow I think I'm going to be learning TypeScript on the show. I'm going to, probably earlier in the day though, afternoon, I'll start up the show and learn TypeScript with Fuse. And just because I don't know TypeScript, and apparently we're standardizing on TypeScript, so I'll do some TypeScript. And later in the week, if I actually get a chance, I'm actually going to start doing the Leaf show. I have one more thing to do. I have to implement the size of operator. Yeah, cries, but TypeScript is better than JavaScript. That's like, better, it's just when your options are like that. But later in the week I have to do one more thing for Leaf. I have to get my size of operator working, because the GL, I need one more OpenGL class that requires size of, and once I get that working, I'm going to start my show for creating a game. I'm going to try and create the Worms or Tron game from here, and we'll be doing that in Leaf with SDL and OpenGL, and I'll start the show with that right from the start. As soon as I have the OpenGL stuff, and I'll be covering, then we'll just write the whole game online. We'll keep doing Evening Rust though, of course. And I get to switch back and forth, but I'm happy Leaf is actually far enough to do that. And yeah, this is a degenerate strategy here that's working. And what else do I have in shows? That'll be good. And once I have that in Leaf, I can actually start showing for these things as sort of a sideshow to this. I can start showing you, well, what does this actual flood filling stuff look like? I know a lot of our chatters actually know what we're doing. You can visualize it, but I mean, a lot of the viewers, you may not. It may be very hard to visualize what the hell I mean when I have all these boxes and I flood fill back to my position to determine where the best position is. Like, what exactly is I doing? If you had a grid visualization on the screen and I could step through it, you'd see very clearly what's actually happening, and that would probably be helpful. So 33, we're doing quite well. Anybody else with Rust in this league? There's this guy that builds our cargo builder, and he's online, not playing this game, of course. We're already following him. And Blue, Blue has a negative, so he probably just snuck in from the previous league. We're already following Epens. He built our builder. Great, let's just do it offline. And we have another guy from Norway who's doing Rust. And I wonder if he's one of the guys working at Fuse. We have some people there in the office that like doing Rust. That's up in Norway. And that put me back to around me. So before I do the don't move one, and do I actually get to the next strategy, we don't necessarily have to do the generate strategy to get the next one. I'm assuming the breadth first search would also work. Just do like a 1 level depth, that would also, actually no, you can't do 1 level. Well, this is curious, Petrosol. So you only do 7 steps deep. But if your bomb actually has a range, if you build up the range to more than 7, you're actually limiting the possibilities, because you can't actually walk in the direction of the bomb out of the way. You'll never actually walk the direction of the bomb to get out of the way. You have to go to the side. which isn't necessarily bad, but it could complicate things. So now I'm considering, do I actually want to bother doing the degenerate, kill a few boxes to actually get to the next league? Will it actually help enough? Alright, let's just see, let's let this play out. If it's really only like one box we need, then we can do it. But it's a lot of sort of, it's not a lot, but it's enough sort of manual code. It's a lot of little grungy little code to figure out what we should do. Okay, yeah, Petra, so yeah, I assume you did that. I assume you did if you're standing in the range of a bomb. Or you mean even if it's not gone off yet? I got it. So at the end, I get it. So even if the bomb hasn't gone off yet, you're not going to end in the stream of a bomb. That makes sense. Whereas if you end, obviously during the iteration, so I'm assuming, Petra, when you end, if at any point you're actually inside the flame of a bomb, you give that branch a negative infinity and prune it off. And Cry said he's just ignoring that altogether. Cries, how do you mean ignoring that altogether? Obviously you have to keep yourself safe, don't you? You can't just completely ignore the bombs. Well, maybe you should avoid standing in them, and then you can get a bit further. But don't you just die? How do you not die by standing in the bombs? Let's look at one we've lost. We still win so many of them. It's just... So watch these guys here. Let's watch them all kill themselves. You probably can't see the whole screen. It's unfortunate it's on the left side of the screen, so I'll shrink that again. You have to see the small mood. Yeah, so these guys probably just end up killing themselves. Oh, so the purple guy, he failed to consider he got an item. So he actually walks out of range, but he forgot the fact that he got an increased range. And so Cries, I guess you're using a heuristic to decide if you're within range of death. And why does this blue guy die? I'm curious. How does the blue guy die? Oh, he forgot his own bombs. It's 100. Yeah, Christ, if you're doing a search though, that means you're pruning off that search tree. And you're scoring it. Doesn't that basically mean you're basically giving it a negative infinite score? Is that not the same thing? I mean, if you're pruning it from the tree, it's the same as giving it a minus ridiculously low score. Or do you just mean of the 5 potential actions, you only check all 5 of them and see if it's going to result in death? Not at every level of the tree. So we still slowly go up here, and you can see these other guys just end up killing themselves. I'm going to go by player number 2. Delete him. Where's player number 2? Add this guy. And we'll play him. Come on, edA-qa. We beat edA-qa. Why? Why did we beat this guy? What happened? Yeah, but we only did 47 moves. Cries, yeah, okay, Cries, that's what I said. If you filter them out, that's basically the same as giving it a negative infinite score. You're pruning off the tree. And so that makes sense, but why? What happened in this game? Okay, so yeah, okay. Anybody know what happened in this game? So if we don't do anything, it ends the game? Well, okay, that's weird. So we're going to tie this guy forever. Why does he move? Oh! He's not even staying in space. He's actually trying to move to 0,0. So his strategy even has less logic. He just moves to 0,0. That's weird. It's like the one-line strategy. Just flush standard in and move to 0,0. So that means we still have to be going up, and we're going to end up tying with him because he doesn't make it to the next round. Means we have to kill at least one thing, one box. All right, let's try to kill the one box, and what I'd really like to do is actually encode. No, I don't. How can I simply do this? I want to do the logic. It's like I want to move up or down 1, place a bomb, and then move 2 away from it. Alright, let's do it this way. Do we always have... Are we always in the corners? Yes, we are. Yeah, I think, but if I'm almost winning now and I can beat a few ties, I mean, if I can beat this guy several times, that should be enough to push me up in the scoreboard. And because he's like really high, and if I can win against him a few times, that would give me enough points probably to make it out. Right, so I'm just going to try that. But how can I do this simply? That's the question. How can I actually do this really simply? Because I don't want to spend too much effort on it. Because we have to know where our moves are. Oh, I know how I'm going to hard code it. It's because there's something I've observed in the game. You notice when you start the game, there's always a spot and 2 sides of you free, and then usually a box within range. This one here, I'm going to miss out on a box, but in the vast majority of cases, if you just go right or left, place a bomb, and then go the other way and go down, you're going to destroy one box and be safe. So this is what I'm assuming, that virtually all of the boards have that. Like if you play this again, and I think they do this because it's the only way to ensure you can place a bomb and be safe. So the random level generation basically says always make these 2 free to make sure there's a safe place to put a bomb. And so that means how I can hard code it. I basically look and I walk to one of these positions, place the bomb, and then walk to the other one. I'm just trying to think of how I can quickly hard code that. See, here's the same thing again. And so it's very easy. Logically, it's very easy. Just from code-wise, how can I do this really quickly? And so I just have to identify 2 spots, the bomb spot and the safe spot. and then I'll be okay. And I think I can do that. We can just hard code that. And it's going to be the first turn, so let's mut iter equals 0. So we have all of this here. We have the player here. If iter equals 0, we're going to find those two spots, because we have to know where the player is first. And then we're just going to do let mut bomb spot. It's an I.2. Oh yeah, this equals I.2 0.0. Let mut safe spot equal I.2 0.0. Yeah, but recognize I don't have a fancy stat yet. I don't have that at all. Mine is basically going to be, because I don't avoid my own bombs right now, so I don't have that one to fall back to. I would actually have to implement the simulation, and I want to see if I can get by here without implementing the simulation, if they generate one. And if player.position.x equals 0, bomb spot equals player.position plus I.2 at 1, 0, player.position.y equals 0, safe spot equals player.position plus I.2 at 0, 1. So this is really cheap. I think I can do this quickly, and I hope I do logic. -1. It's going to be the same thing down here. Otherwise, it'd be -1. And the safe spots are still the same. So we can actually put those up. The safe spots are always, let's just leave it like that. So iteration 0, we get the first spot and the bomb spot. And we're going to have one mutable for let mutable bombed is false. And we'll just do that. If not bombed, if player.position equals bomb spot, then we're going to bomb it. Print line bomb, and we'll start moving away immediately. We'll do bomb to safe spot.x, safe spot.y. Otherwise, we're going to move towards the bomb spot. Bomb spot.x, bomb spot.y. Else, we just move towards the safe spot. Move safe spot.x, safe spot.y. And get rid of this. Where did I do this? 25. Oops, I forgot to set bombed. Need to do that. Bombed equals true. Hey Thanos! We're just trying to make a really cheap strategy to get out of the Bronze League. We think it'll work. So now I'm trying to bomb one box and then sit still. And you notice I do a lot more now. Ha! Why am I not dropping a bomb? Why am I not dropping bombs? player dot position and bomb spot. Where's my bomb spot? So Thanos, we made it to the Bronze League with a fairly simple strategy, and a stupid strategy makes us to the top of the Bronze League, but we're trying to find a way to kill one box just to make it the Silver League before we implement the correct strategy. Alright, so what am I doing here? X is 1, 0. So he's moving to there, and he's not dropping the bomb. Oh, well, I should probably drop it on bomb spots. Duh. No, I can't. Do I ever say bomb? Go right to the top. Move. Move. Well, this is weird. What am I doing wrong? If not bombed, let's do that as well. Bombed. And let's do the last one as well. Something fishy here. Player.position equals bomb spot. Why is he not dropping the bomb? Because it should be equal to bomb spot at some point. Alright, so what am I doing wrong here? What's happening? False, false. It's not bomb, that's correct. But the second one... Oh, crap. Spot the error. You know, if you have an iteration counting the rounds, you should generally just make sure you increment the iterator. So look, we're at rank 7, and this is without the bombing. So now we're going to try and bomb one box, which will let us win against this guy, we think. Except for boards like this. So we're going to still sometimes lose. But we'll win 50% of the time, because half of the time there's boxes on the other side. So right, so this one we win. And this is just enough. We'll win against him sometimes. So there, we got our 1 point. Thanos cries while completing. He's way up in Gold League, so he's left us behind. So he's doing really well. And let's submit this one now. This lets us win an infinitesimal small mort-ora matches. We don't always bomb one because I hard-coded it. It's very easy to change it to so we actually... Well, not very easy. It's relatively easy to change it so we always bomb one. And, okay, that was really simple. Oh, wow, that was a fun one. Look at that. It just died. Alright, so we're winning there. We're just going to watch these random battles. So, on it looks to be like about 60-70% of the boards, I will now bomb one box. There will be a few boards where I don't. Like this is one I won't bomb one because I only ever bomb here, 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 here. But I still win some of them, and so I'm hoping this gives me just enough of a lead to get up to the boss. Because it's relatively easy for me. And this guy just ends up killing himself, so... And that should be enough. It's whether the speed makes it high enough to get there. And again, we're doing a stupid heuristic right now. And it's not going to get as far. Even if we do get a Bronze League, we know it's useless, but I just wanted to see if we could actually get it a Bronze League with a degenerate strategy. And this qualifies pretty much as one. We're not checking dynamic state. We're just basically saying first move, go somewhere, place a bomb, and otherwise just go to some other safe spot. Let's look at Cry's difficult position here. Yeah, okay. Well, Cry's, this is the exact position that my stupid bot can actually solve right now. A breadth first search, of course, is going to solve this one. The breadth first search with the state simulation would obviously solve this no problem. It's going to realize that on turn. While the timer 4 is difficult, you actually have to go down to. This is why you need to go to at least depth of 5 to actually see the bomb explode. Although Petrosel said in his leaf note, if he ends up in the path of a bomb, he also negatives the score. So his mode actually work any level of depth would also avoid that. Alright, we're crawling up the leaderboards. Actually, a little bit faster this time. And we should be able to make it by that edA-qa now. Yeah. Fun, fun, fun. Slow, slow, slow. Yeah, so I think our strategy's set for pretty much. I don't know which day I'm going to do it, because I don't think I'm going to do it now. I don't think I have enough energy left to code the simulator now. But what we have to do is code a simulator. And by simulator, what we mean is that when we play these games, even ignoring the enemy, we have to, for each of our moves, because we're going to evaluate a move, regardless of whether we're doing A-star, depth first search, Monte Carlo, whatever you want, we have to be able to simulate what happens. And that means if I move here, I have to have a board where I'm there. If I place a bomb, I have to have the countdown for the bomb. I have to track the scores for the bombs, and I have to be able to apply this. And so this is what the simulator will do. The simulator will basically will track that state. And regardless of what strategy we use, we're going to have to use that simulator. Now, why does this blue guy die suddenly? What happened there to that blue guy? Oh, I'm willing to bet that blue guy had some kind of depth searching and he timed out. That's more likely what happened in that one. And I really don't like this interface here. Yeah, I don't like this interface here that the moment the thing is done, it immediately jumps to the next one. You have zero opportunity to suddenly say, hey, look, wait, pause, I want to see that one happen. But that has to be what happened because I think he just timed out. Just disappear. Yeah. Well, debug mode has random things for that. Like debug mode, you can suddenly have weird timing issues. And we actually had that in the competition too with Euler. He told us to play against him. In the first battle we had against this gold bot, we won because he timed out on the second move, and he'd never seen that before. That was kind of funny, but debug mode, weird things happen because you just never know when the operating system's going to decide to do something on you. Because that one little extra memory allocation, that one little loop, it's literally non-deterministic, whereas in release mode, if you avoid a lot of that, it's unlikely to happen. It still can happen, and it's just very unlikely because you're not doing as nearly as many system calls in release mode, or you shouldn't be. And this is hilarious, the strategy works. These guys just end up killing each other. We just sit in this corner here. I bomb my... This one I didn't even get my $1. Oh, this one I lose, though. So the purple guy also just tries to do a safe move. But we're going up, and I actually die there. So this Karan guy, I'm surprised that he's still in this league. He clearly looked like he was doing, he's at 11. He looked like he was okay. Is he going up? Let's start checking the leaderboard now. Oh no, Karan, you can see it. He's going up. I'm assuming he's going to get out of this league because his bot looks to be doing fairly intelligent things as opposed to ours. And yeah, I think their system sometimes just has hiccups too. Like just weird things happen on their system. It just like something goes wrong. In all of the code we've done so far, to meet their time limits, I've actually had an explicit timer. I just check the time and I break out of my infinite loops as soon as we run out of time. So I don't have hard-coded depths. I never did. This one will probably be similar. We just won't have a hard-coded depth. We'll just, like, the moment we run out of time, back out. And that prevents those occasional blips where you lose for no apparent reason. And if the blip happens to affect both players in the system, which is unlikely because you're running at different times, then... So this is one here where we win because we're playing against the guy that's have the same strategy. He's doing nothing, but we bomb that one box, and that's going to give us the 1 point to get up. And surprisingly, we passed it past Kerrang, so... In the leaderboard, we're on the first page now, going up. And we're probably the guys pushing this one down a little bit because we know we occasionally beat him. And I dropped again a little bit, but that's okay. Probably if we just wait and leave this. So I don't know what's... I probably won't do this. So what do we have? We have to do the simulator and then one of Brett first. Temporal A star, or if we're not doing Monte Carlo again. Let's just close that one off right now. I've had enough of Monte Carlo from the tic-tac-toe for now. And if we do it, we could try the fractal AI. The paper looks really promising on it, though I don't truly understand why it works better than Monte Carlo, other than it's using less iterations. It seems like it would be biased towards things that have early success. But they used it primarily on old Nintendo games and that type of stuff. Games that have a very clear score. They should play, for example, 2-player, you are player 1, then switch should happen. So, Petra, so you mean like... Yeah, it used to be like that. When you played 2-player, you'd switch spots, and if you played 4-player, you'd all have a fair shake. You'd all start in the correct places. Yeah, it could be just bronze. They just don't care in bronze. You deal with it. Because I'm clearly not getting 16 combinations of these things. Nor am I even getting 2-player combinations. It's entirely random. It's not doing any of the shuffling of them. Well, that's really weird that it doesn't have it. Because they do that in the newer competitions. Maybe these older competitions just don't have that. Because the newer ones, the reason... So what Petrocel's talking about is that when you play a guy, they would immediately play the exact same game with the same randomness, but switch the starting spots. And the reason you do that is to ensure that nobody's getting lucky. So you both have the same board. In the Tron game, that was vitally important, because in Tron, you had unwinnable positions. That is, if you're both... They're just unwinnable. But maybe the case is, if for Bomberman, maybe the issue of unwinnable positions is not a big deal, because it's hard to say you have unwinnable positions on this board. And you know what? There's another reason why you don't need it here. Because these boards are symmetrical. You have no disadvantage based on where you're starting, except for perhaps your position relative to the other players and their strategies. But there is no negative position on the boards. And so I'm willing to bet if this box here has one item in it, this box here has the exact same item in it. And that would make the board entirely symmetrical. It means you wouldn't need to alternate back and forth because there's no disadvantage to starting position. Alright, so we're up to number 3. It has it for 3 players? Well, no, right here we don't have it for 3 players. Otherwise, you'd see a bigger group of 3 players. Weird. Whatever the case, but that's... I don't think it's necessary for this one. Maybe they optimized it out. Maybe they're trying to cut down server cost. Oh, wow. So somebody's pushing up this guy up here a lot. Could be us. As long as we keep going up for us. Petrosel, that is actually, you're absolutely correct. The player position could make a difference, but the truth there is that, well, that's your strategy though now, right? It's not like in Tic-Tac or in Tron. In Tron, you really had unwinnable positions. Even if you played the best strategy, there were unwinnable positions in Tron that made it absolutely necessary to switch. And I have a hard time believing that'd be the case here. That there's some way you can be in a position on a symmetrical board where the other player's position is guaranteed to kill you. I just don't see that happening. Whereas in Tron, it definitely was. And in Tic-Tac-Toe, because that game isn't proven, we just don't know if starting had a better advantage or not. But they just switched it back and forth there too. So our score's going up. So we made it back to edA-qa. And that one extra bomb we did. So the theory so far is holding up that that one extra bomb might push us high enough up. And our score keeps going up because it looks like we probably beat enough people. And yes, okay, Petrosel, you're making a convincing argument. It's not fair. Starting position is different. But again, it's saying it's that it definitely does make a difference based on player position, but it's not nearly as significant as some of the other games. And clearly the guy that has two people boxing him in has a disadvantage compared to the one that has one on the side. Everybody's going down. This is really weird. Entire down arrows here. Everybody's absolutely going down. Nobody's going up. That means there's somebody coming up the leaderboard which is doing better than us other than the boss. Ah, there we go. We're going up again. I think we'll probably make it here. Anybody else with Rust come in? No, we already know them. Who else is from Germany right now? So many. Anybody else from Germany here? All sorts of Germans in here. They like this game. Let's check for my fellow countrymen. Canada. Do we have anybody from Canada? We do, and I'm above all of them. Oh, of course, I'm above all the Germans too. Of course, we're only in the Bronze League. Somebody online. All right, where are you? Come on, are we going up still? We are. It looks like we'll probably get to the next league with that one bong trick. Is edA-qa even an active player anymore? Level 9. We have no idea to see when they're last active, do we? They don't... Oh yeah, they've been active. They went up recently. Or maybe it's just accident. Have they actually only played that one game? Oh wow, I can't read that text. Is that Piano Masters? Hello, Piano Masters. Welcome to the show. A dab? What's a dab? Cries, yes. How to win it? Cody, yeah, but there's one weird trick. No clickbait involved. What's a dab? I don't know what that is. Wow, do we actually have to destroy 2 boxes, or will we sneak up? Now what the hell is that? This is not... What is that? I can type that too. Yeah, I don't know what this is, but here, you can have one. I gotta have a book of lingo somewhere. Streamer. I see I'm not up to date on this stuff, and I apologize if I don't know the proper streamer lingo. I gotta write this one down and look for history. So next time we're gonna do a history lesson of what this is. Dab. Oh man, do we have to actually do a strategy to get past this level? Come on, no. I'm blindly opening these things. I trust my viewers. Oh no, I forgot to close the tab. Oh. The dab. Okay. I'm missing some cultural meme reference. The hell is this thing here for? I'm most curious about this thing. Tuner dab. DAB plus digital OK. Alright, so we have dabs. Which one do I like? I'll just pretend I recognize everybody in this page. Alright, I don't want to do a strategy. Come on, let me sneak through. Be nice to me today. Boss has to start losing. So I definitely beat edA-qa. Who am I losing against now? Let's find some losing battles. And the problem is the losing battles we're probably actually going to have to... Christ, I don't know. It's really hard to say. They usually just pick the boxes for something that's stable. What do you mean, Petrosil? I mean, I'm on the full leaderboard. Which replay am I supposed to be looking at? All of the other strategies are like complete strategies. I'm just looking for the one degenerate strategy, and our degenerate strategy is better than edA-qa. What's that? Oh, full leader. Okay. Uh-huh. Spam, the spam guy. Okay. There's Euler down there. Ugh. The interface is wacky. View last battles. But these all have like actual good strategy. He lost the last one. Let's look at this one. That doesn't matter. See, like these guys have actual strategy. There's nothing here I can pick up really cheaply. We know any level of breadth first search is going to work. I'm being terribly lazy right now, and I want to see if I have a cheap strategy to get by the day without having to do any more coding. Whether I make it or not, next time we'll actually do the breadth first searching. And then we could tweak the strategy. The strategy can basically tweak is only do bombing as long as we need more points than the other guy. With these types of games, it's very hard to see what the strategy is because it's very clear. These have a very fixed, clean strategy. All of these guys have a very optimized type of move. They all know where the bombs are going when they go off. Yes, I see that. They actually have... And Christ, this is the problem if you do just pure heuristics, is that the breadth first search doesn't have to understand things like chain reactions. I mean, the simulator, it just whatever the simulator supports, the breadth first search automatically considers. But like these bots here are all amazingly impressive. Piano Masters, yes, that's what we're doing. We're teaching bots to play games, and these are the masters in this one. This is the Legendary League right now, and what we're doing right now is our bot is over here, and I apologize that our bot right now is being stupid. He does nothing anymore. He was more interesting before, but right now we're cheating. Well, kind of cheating, and that our bot just plants one bomb and then sits here. Because it's a really good strategy for right now. But the next show we're gonna have to actually implement the simulator. And Petrosil, well, I lost it again. Let's go back to the full leaderboard. And so again, we're just hoping we can sneak through. But next time we're gonna have to do full leaderboard regardless. But we have like a 2-point gap with Bossa Nova here. And it depends on what other people do over the night, whether we sneak through to this. But there's not a lot of people playing games here right now in Bronze League. The best chance we have floating through is having a lot of people. Piano Masters, at the Legendary League, I highly doubt it. The game is too fast. Guaranteed if the game was played stepwise, like turn-based, a human would probably win. But because the game is played real-time, there's just no way a human's going to figure out the chain reactions fast enough to figure out where to place the bombs and get them, because they're playing amazingly fast. And let's find Petrosil on here. Petrosil. Petra. Why does the search not work? League, coding game. No, people I follow. So we're looking at Petrosil now. Petros, that's right. Yeah, there we go. So if you look at some of these battles, you're not going to... The level of complexity is too high. And I can't make this bigger. I'm really sorry. Because it's right aligned, if I maximize it, it'll be cut off by the side of my screen. But if you look at the number of bombs here and what's going on, there's no way. It's highly unlikely a human player could beat these guys. Unless there's a trick. Unless there's some degenerate trick they don't know. But then they'd simply fix their bots. But if it was turn-based, a human probably could do it. By turn-based, I mean everybody got to time their move, then they see the results, then they do the next move, then the human could probably do it, but it would take them really long. And so we're watching Petrosil, this guy right here, Petrus. His bot is, compared to the other guys, a lot less hyperactive. And, well, he killed himself here, but that's okay. If you see the number of bombs here involved... Like, I used to play Bomberman a lot before, like, as a human player, and I would just, my strategy was to get a lot of bombs and just bomb everything, because it was very easy to stay out of the range of bombs, but, it's a hard game to begin with. So what we're going to have to do next, and I'll do this next show, is we're going to have to build the simulator. And by simulator, it means that for every given state the board, for any given move I track what happens with the board, and we're not going to care what the opponent does, because we're not going to predict what they do. And chances are that these guys at the top of the Legend League might be predicting what the other opponent does. And this is really a time-based thing. Knowing that there are optimal strategies, if you had all the time in the world, for every move, what you would do is you would calculate the potential best move for all the players and then compare that based on your potential move, and you do this through every step. And this is an extremely costly calculation, though, to do that. And so most of these guys, as Petrosil confirms, that He's just ignoring the other... He's not ignoring the other players, but he's not predicting what their moves are. He's watching their bombs, and since every step of the move you see what the opponent does, it usually works out alright. But you notice all these bombs stand in spots. That's very interesting. My guess is that this is not an optimal strategy, is that somehow moving, but it may not be. Alright, so that's where it is. Where am I standing now? And look, we were actually going up. We might get lucky. But there's no games being played left. So overnight, what I'm going to... There's a good chance... So Petrocell's strategy is, pretend you're in an empty room and bombs are magically appearing. Do I put the boss down, Petrocell? Piano Master, I'll get back to you in just a second. Yeah, but I don't think that's me putting him down. I think that's other people, because I'm not playing anymore. And if I resubmit, there's a good chance I push the boss back up as opposed to back down, because it took me a really long time to get here. So I think if I just wait here for people to submit, I'd probably make it. Piano Masters, that was a previous game we played, and there's no one else submitting, so we're not going to make it anywhere. So fine, let's just resubmit. Go for it. Piano Master, that was the last game we were playing, was tic-tac-toe. It was super tic-tac-toe. It wasn't 3D, but it was a 3x3 grid of tic-tac-toes. And what we were doing is we were doing a Monte Carlo search. The Monte Carlo searching is searching through all the potential moves. For each individual move, we just evaluate, I want to say thousands of games for each move, but our performance was so bad. Section compute. Oh, really? Okay. Uh-huh. Oh. Yeah, okay. So there's... Yeah, okay, if I'm knocking the boss down, then this will be great. But I don't think I am, to be honest. I think I'm knocking the boss up. So I'm just killing time now. Again, but yeah, Piano Master. So your option for tic-tac-toe is Monte Carlo, but you have to do a lot of iterations. If you have lots of time, you can do it. But if you're already having a problem with slow, we had like 100 milliseconds. In a release mode, I think I was doing 10 to 20,000 iterations from full depth. If you have a second, obviously it just goes higher and higher and higher. But as the game progresses, you can actually do more iterations to get closer to the end, but it was uncertain whether that would be sufficient or not. But the scoring system, what else would work? We don't know what else would work for tic-tac-toe, to be honest. This is why we stopped doing tic-tac-toe, because I just didn't know what other strategy to use. I mean, we just didn't know. The next step we were going to do is that the scoring was fundamentally dependent on what we predicted would win from a given state. Is the next step we'll be doing a neural network to help us predict that, but we didn't feel like doing that, plus we had no strong indication that it would actually work. So we gave up on tic-tac-toe, and we came and played this game because it's got better graphics, and it's more fun. And where am I on the board? Going up, and there's still nobody computing. We're doing fine. We're going down. We're going to go up. And you're welcome, kind sir, as well. On this one, what we'll be doing is a breadth first search. Monte Carlo was an option, and I want to do an A-star just because I haven't done one in coding game yet, but it's going to be, and the reason it's going to be a variation is I'm going to do a weird temporal A-star, so as you step through, we're actually stepping into the future of the grid. It's not a fixed maze or anything. And A-star doesn't care about that. A-star just basically says walk through the states and just take whatever state. And the state doesn't care if it's in time or not. It's just a different one for us. But it might actually be really costly because A-star requires you to jump randomly through a bunch of states, which means we're actually going to have to keep full clones on hand. Oh, I never thought of that. A-star is going to require us to keep a full clone of the state at any given point. And Petrocil? Yeah, I think so. Except for the thing I just mentioned now is that we're going to have a huge problem is that A-star requires in my open list to have a full copy of the state. I have no shortcuts there. I can't reuse anything. Whereas the breadth first search, I can actually use undo operations to keep modifying the one state and walk through it. But an A-star does not have that option. An A-star is going to be a complete duplicate. And the advantage with the A-star is that it helps you, it does a goal. As opposed to the breadth first search, it'll help you reach a particular goal and help you decide on it. The question is, it's more heuristic based then, right? The goal is heuristic. I'm going to have the same goal I have now, go to the place where the boxes have the most score. But that's in a heuristic. I don't know if that's actually the best score. I'm going to completely omit things that have higher scores, so I don't know if it'll work. And for that actually, now that I think about the scoring thing, because of the complete duplicate, I'm just going to do the breadth first search because keeping a copy of the state around is just not, it's going to kill me. Not having the copy, but the actual copy operation itself is going to kill me because there's no way to optimize that. If we were in release mode, I don't think it'd be an issue because we could optimize just one block of memory, and copying 1K of memory is really not an issue. We could copy thousands of those. And I mean, it's still a lot of cycles. Copying 1K of memory is still a lot of cycles to do compared to, well, not copying. Okay, so we are pushing the boss down, but like very, very slowly. So we might get up there. Alright, so next time I will write the simulator. That's the first thing I do is write the full simulator. Regardless of whether I make it out of this league or not, I'm going to write the simulator first. And we don't have to consider everything. And then we're going to start the breadth first search. And that's the exact way we're doing it. And initially we're just going... We can still do the heuristic to get what our target square is, because our breadth first search is more than likely going to give us a lot of equivalent scores. And this is really important, especially if your search is very low. Like if I only say we want to test with a 3 depth. At the 3 depth, there's a very likely possibility that your guide just sits and there's too many equal scores. And the problem with equal scores is that you end up going back and forth between 2 positions because you move, oh, now it's slightly better. But if we actually have the heuristic as well, what we do is we bias all the scores on their end score, basically saying, well, how close am I to the place I want to be? And then that would get rid of that bias and make us stronger. And Petrocil, he said he's doing the same thing. What he's doing is if his search ends in a place where he's in range of a bomb, he decrements the score there too, and that helps remove dangerous ties. So basically what he does is that if you end up in a bomb, well, decrement the score a bit because basically it says anywhere that ends up not in a bomb is safer, and so basically just don't go there. And I think our theory is that because nobody else is computing, we're not pushing the boss down. We're pushing the boss up and down. We're getting lucky. So we'd actually have to, if we want to get by here cheaply, we'd actually have to modify against the boss. But it's not worth it to get by cheaply. We already spent enough time on that. We're just going to go to the simulation because we're fairly certain a simple depth first search would work. And we do win against the boss sometime, which is weird. So we might do it. So let's go back and see the boss. Let's see how often we win against the boss. Bossa Nova. Let's play him. The only reason we win against this boss is because he kills himself. So this boss must quite often kill himself, because there's no other way we can beat him a score. So this one, I assume the boss killed himself. Yeah, right there. Disintegrated. So this is our confirmation, basically, that the boss, because he disintegrates, and a lot of other players do, and our degenerate strategy works, is that a breadth first search, even to like 3 deep, would be perfectly fine. And by breadth first search, what we mean is that when I'm in a given position, I'll play it again, what you do is you check all the possible moves. There are 6 of them. Petroso only evaluates 5, which is actually really helpful to cut that down. And for each move, you simulate the move to that one and count your current score. And you do that to a level of 6 deep, or however deep you could possibly go. The deeper, the better. And you just take the one that ends up with the highest score. And you score a death. If you ever die in your simulation, you score that really, really low. Actually, you prune that out of the tree entirely. You just say, don't go that way. It's not a valid option, because you're dead and your game's over. And negative infinite score is the same thing, except pruning's better because it stops the evaluation. Otherwise, you'd keep evaluating there. And it looks like I don't fight him off enough. And I'd say a simple breadth first search here would probably beat this boss. Well, it's going to. But he kills himself often enough that it's kind of basically a luck game right now. Are we going to beat him? It's a luck-based game. We're so close to each other. And I don't know how it assigns the other players. We tend to do better against the other players than him, but it looks like we could just get lucky and get to the next round. And then there we know we have to do the first search. Again, so this week what I'm going to do is tomorrow I'm going to hopefully, I'd say hopefully a lot, I'm going to say hopefully once more, start learning TypeScript tomorrow, because that's what I'll be doing at work. So if anyone's interested in TypeScript, you can check me out tomorrow. It'll be during the day. I'll upload the video after as well. And we just made it to the top, so we snuck by here. Wonderful. We snuck by. We'll go to Silver League. That's a good way to start. We're not going to make it anywhere in Silver League. And so tomorrow I'll do TypeScript. On Wednesday, maybe more TypeScript. Hopefully at least once this week I'm going to start doing Leaf, but actually it's fully dependent on where I am with the graphics. I need one more piece of GL. Let's see if my GL stuff's actually working right now, if I left it in a good state. So this is how far I am with Leaf. And you know, this totally doesn't look impressive. But let me tell you what's behind this right now. Leaf is my own language, and I'm using SDL image, and GL, but the rest of the code is my own programming language, and I've written a compiler for it. And so the reason why this is impressive is because the entire setup of SDL, the entire setup of GL, and all my code to do this simple animation is all done in Leaf, and so that's a pretty big step for me in the compiler. Cries, it's both. Well, actually, no, it's not interpreted. This mode here I'm running in is just it's a feature of LLVM. That's the back end of LLVM. It lets you compile and run in memory, so you don't have to actually create an executable. And so this is still technically compiling it. It's just doing it in memory. And if you want an executable, you just take an executable and create one. So this creates the executable that does the exact same thing. And so that's the option. I wanted to make this working in Leaf. I think it's good. The simple mode where you don't have to generate exe makes the turnaround time really fast. And there's no like progressive compilation or anything. This is actually compiled every single time. It's probably about 2,000 lines of code, and it's all running in debug mode now as well. And so it will be faster, and we'll put this in libraries. But what I'm going to do, I have one more thing to do. I have one more buffer to complete in OpenGL, and I need the size of operator in Leaf to do it. And it's the one more thing I have from the compiler, and then we'll start writing a game in this. And the game will really be, it'll be very challenging in that I have no standard library. There's a lot of language features missing, but that's what's going to make it the most fun. You guys can watch right from the beginning. the challenging part is not the game that's so much challenging as the compiler, and we're going to choose simple games like the Tron game, the Snake game, because it doesn't require a huge amount from the code at the start, so it's a fun way to start, and it's a simple way to start. And then we'll start doing that hopefully this week. I don't want to... yes, Cries, yes, it's written in C++. The actual compiler is written in C++. And the level of C++ it uses is far beyond what my code can do yet, but I'm going to work on it, and I got to clean up a little bit, and we'll see what happens. But hopefully I can start doing that this week. If I get the size of operator written sometime in the week, I'll start on Friday with the game, and then I'll keep publishing those, and then we'll switch back between that, primarily between the game and Evening Rust, and maybe a bit less of Fuse. I'll keep doing the TypeScript because, you know, I have to learn it anyways, and maybe somebody else wants to learn it. But that'll be the direction I go with there, and getting that to work. And then SDL presents a lot of opportunities, and it's just great fun because I was lacking focus in Leaf, but doing these games will be great fun. It's something I always wanted to do. We can do the sound, we can do the gamepad input, everything, and I get to keep working on the language at the same time and building a standard library, because standard library is rather important. And so we're actually doing quite well now. I don't know why we're doing so much better this time than last time. That's weird. A lot of randomness in the scoring. And so we're number 1. I'm just going to keep waiting to see what happens there. And this is like winding down to see what's happening. Come on. 1 minute left, and we get to promote to the next league. Or, the hell is this? Oh, we might not go to Silver League. We might have to wait overnight because it's going to be like an hour before we get there. Alright, so we're not going to wait for that. Cries, right now memory management is done with more the C++ style. It's implied reference counting. So it's actually at a high level. At a high level, you don't worry about it. So basically, from a user, you generally don't worry about it. It does not collect loops. Let's just say it doesn't do loops, but all the other memory is automatic. It's currently using reference counting. What I'm going to do is the optimized stuff, like Rust has a lot of move semantics, and that optimizes it. In Leaf, my goal will be to do that during the optimization stage, because I can actually detect most of the cases where I don't need reference counting, and then I'll just ditch the reference counting and use moving instead, and we'll add moving operators there as well. I don't want to get it as complex as C++ because C++ ownership it's become kind of a headache to deal with. There's just too many operators, too much to deal with. And in Rust, I mean, I don't like the move by default. I understand why they did it, but it's also complicated. But the idea, of course, in Leaf is that you just code and the memory should take care of itself unless you have a loop. Loops are very difficult to deal with, but I don't intend to doing scanning garbage collection because I intended to use a system language, and they're just incompatible. You simply cannot have a scanning garbage collector and expect to be able to write low-level libraries, drivers, or anything like this, or even high-level libraries. And I want Leaf to be the language that can do libraries, like font libraries like STL, GL, and this type of stuff. And none of those can really have a scanning garbage collector because it's just not going to work if you want to include it in the library. If something has a scanning garbage collector, I'm keeping the memory model high enough that if it's already there, then yes, we can use it. We'll make it an option, but that's not my goal right now. Alright, so it looks like we have to wait 40 minutes for Silver League, so we're not going to do that. I'm going to sign off for the day. We're in Silver League. That's good enough. And let's just commit this. Commit the stupid approach. And tomorrow we'll redo something. Not tomorrow, but later this week. Thursday night, Friday night, we'll do the actual start on the actual simulator. And this will be blend well with the actual Leaf thing because the simulator, the 2 game code will line up. They'll have very similar approaches. You can see how it's done in different languages. And then again, I'll start explaining in Leaf also once I have the graphics library how our filling strategy and stuff works here so everybody can see that. But thank you very much for watching, and I'll see you later this week, tomorrow if you want, or Wednesday, and then sometime later this week. Thank you very much for watching. I hope you enjoyed it, and we'll see you next time.